Okay, so we're starting up our class, and this class is on digital forensics. And digital forensics, the subject matter we're going to be covering is steganography. If you haven't made an account over at TryHackMe, then you can please go ahead and do that because we're going to be using that platform. Anyways, let's go ahead and start the class. All right, so what are we doing today? We're doing HackerFrogs after school. So this is digital forensics, and we're learning about steganography today. So if you haven't heard of the word steganography before, that's perfectly fine because it's not a common word, and it's particular to stuff in cybersecurity and in cryptography and stuff like that. So this is the second session. We're going to have about 8 sessions for this particular. There are going to be 8 sessions in this course. And let's go ahead and start. Okay, so welcome to HackerFrogs After School. Hey there, HackerFrogs. This is the second Intro to Digital Forensics Basics workshop. In the previous workshop, we talked about the following digital forensics concepts. So let's just do a short little review of what we did in the previous workshop. And we learned about EXIF and image file metadata. So anytime you've got a picture file, you've got some metadata, that is data about the data inside of there, and metadata is the data that provides information about other data. In the context of digital image files, each file has a plethora of metadata information, which is generated when the picture is taken. So it's going to tell you all sorts of information, like when it was taken, what device was used to make it, where it was taken, and a lot of other stuff. So photo metadata, called EXIF, is easily accessible and can reveal information about the device used to take the photo or even GPS location data about where the photo was taken. So the contents of image files. We learned about the contents of picture files and the difference between text and data. Text is computer content that is meant to be read by humans, and data content is meant to be read by computers and software, and it is illegible if not accessed through the proper program or application. So if we were to open up a picture file with our regular word processor, it's not gonna be something we can read. And the last thing we learned about in the previous session was about embedded files and how embedded files can be extracted and examined using specialized software. Okay, so what are we talking about today? We're going to be doing 2 different things. We're going to be learning about 2 different things. The first thing we're going to be learning about is steganography. And in steganography, we're going to be learning about this particular program that we can use to use steganography. It's called the StegHide tool. So steganography, it's I frequently misspell steganography as steganography, but anyways, it's the process of hiding information in another medium. For example, hiding a hidden message in a picture. So when we talk about steganography, we're talking about hiding messages inside of other files. So we got a little taste of something that's similar to steganography in the last class, but we're going to be going more in depth with this particular concept today. So when dealing with digital files, steganography can be used to embed files or messages into different media files like picture files, video files, and audio files. So let's learn more over at tryhackme.com. So we're going to be using a TryHackMe room to learn more about steganography and the StegHide program. So log into tryhackme.com and then navigate to the link below. It's going to be task number 4. So let's go ahead and provide that link to everybody in chat. There you go. And if you're wondering what were all of the different links and instructions we're going to be using today, I've got this document over here at the GitHub website. And you can refer to this if you ever get lost. Okay, but anyways, let's go ahead and move over to that room. So let's, where's the link? Okay, here's the link. Okay, so this room is called CTF Collection Volume 1. There's a bunch of different challenges over here, but we're only going to be using one of the challenges inside of this room. So I'm going to illustrate what it looks like when you all come upon the room and you haven't joined the room yet. So each one of these Try Hack Me rooms, you need to join the room before you can access it. So let's go ahead and let me demonstrate what that looks like. Okay, so the website looks like this. After you've logged in, you should be able to access this page. And when you access the page, this is called CTF Collection Volume 1. There's going to be a green button over here labeled Join Room. So you can't actually access any of the stuff in the room until you join it. So go ahead and click on the green button over here. It's going to be located to the right. It's labeled Join Room. Click on it. And that's going to give you access to all the stuff in the room. So what we're doing today is we're going to be doing task number 4 from this particular room. So what I want you to do after you join the room is I want you to scroll down, and I want you to, if you've got task 1 open over here, you can actually click on the header over here to close out the header over here and then open up task number 4. So task number 4 is labeled Mon, are we going to be okay? So what we want to do is we want to click on that header. So task 4, click on it. And then we got some ads running on on the live stream right now, but it's okay. We're not going to be doing very much. What we're going to be doing is we're going to go up to the top of the room. And after you go up to the top of the room, you should see this little button over here is called Start Attack Box. So when we talk about the Try Hack Me Attack Box, the Try Hack Me Attack Box is basically a virtual machine that you can use to interact with and solve these different challenges. So scroll up to the top of the room, and then after you do that, I want you to click on this button over here, Start Attack Box. Oh, and for everybody who's in the Zoom call, let me go ahead and get the link for the YouTube stream if you want to catch the YouTube stream. So let me just go ahead and get that one. Okay, so I'll just leave the link to everybody in Zoom. There you go. But yeah, after you click on the Start Attack Box button, you should see that your browser window splits into 2, and there's a left-hand side and a right-hand side. So the left-hand side is going to be the Try Hack Me webpage, and the right-hand side is going to be the Attack Box interface. So it's going to take about 2 minutes for the Attack Box to fully start up, but let's just go ahead and wait for that to happen. So if you're having any troubles, please let us know in the chat, and we'll try to help you out, because we don't want anybody to be left behind. And if you have any questions about anything that we're doing right now, you can go ahead and leave that in chat as well. So one more time for anybody who wants to get the link for the room that we're using. The link that we're using for this room is this one right over here. Okay, so everybody, if your attack box has finished initializing, and you know that it's finished initializing when you see a little message over here, just like this. If your attack box is finished initializing, please type in the chat attack box up, just like this, and that lets me know that that you're ready to go. Okay, all right, that's good. Great. Okay, so before we start the room, let's talk a little bit about what steganography is. And over here, AD says, it says mine is temporarily down. Mine is temporarily down. Okay, so if for some reason you're getting a strange message from the page, what I want you to do is I want you to reload the web page. So just go ahead and click on the reload button. It's usually in the upper left-hand corner, and it's going to look like a circle with an arrow. Go ahead and reload the page. That might solve the issue. If it doesn't, let us know, and then we'll see what's going on from there. Okay, Monish in the YouTube chat says, hello, Monish, nice to see you here. We're just doing a little class on digital forensics, and we're learning about steganography today. AD says it doesn't help. Okay, so when you go to the top of your TryHackMe webpage, do you see the button that says Start Attack Box? It should be about here. Because my attack box is already started, you're not going to be able to, I can't see it, but it should be below the little icon over here. There should be a button labeled Start Attack Box. Do you see that? Okay, so is your web page split into two parts? Is there a left-hand part and is there a right-hand part? Okay, and what does it say on the right-hand part? Does it say that it's loading up, or does it give you any message? It says it's temporarily down. That's what kind of web browser are you using? Are you using the Firefox web browser? Are you using Google Chrome, or are you using some other web browser? Google Chrome. I'm not sure why you would see a message like that says it's temporarily down. Why don't you try? Tornado says mine is still loading. Okay. All right. So some people are still loading up their attack box. That's fine. I want you to try reloading the page. So try reloading the page again. I think there's a keyboard shortcut. The keyboard shortcut should be F5 to reload the page. Let's see. AD says I terminated it and redid it. Okay, so did restarting the attack box work? Is it loading up for you right now? It's loading up. Okay, that's great. Good to hear. Good to hear that it's working for you. All right. So before we start, let's learn a little bit more about steganography. Where are we? Okay, so we're going to be learning about a little program called StegHide today. And StegHide is a program that can be used to embed files into certain types of picture and audio files. So it's a program that lets you put files into other files, and it's in that way you can hide files. So in reality, steganography, it's I don't know if it's all that widely used, but as a as an educational exercise, this kind of stuff is pretty popular. So it's hiding stuff inside of other stuff. So okay, let's go ahead and go back to the TryHackMe page. And in the TryHackMe page, on the left-hand side, I want you to scroll down until you get to task number 5. Sorry, task number 4. So task number 4. When you click on that, you're going to see this file right here. It's this button right here. It's labeled Download Task Files. What I want you to do is I want you to click on that button, and what should load over here is going to be this picture, and this picture of some dinosaurs over here. What I want you to do is I want you to copy the link for this picture. So click on the link until it's highlighted here. I want you to right click and select copy. Select copy, and then I want you to go back in your browser so you can go back to the TryHackMe page. So after you've done that, what I want you to do is I want you to click on the center of I want you to click on the center of the page. There's going to be this button over here that looks like a little arrow. It's labeled Hide Show Control Bar. I want you to click on that, and then after you click on it, I want you to click on the little clipboard icon here. So after you do that, you're going to see this clipboard appear over here, this little box. I want you to click into the clipboard field, and then I want you to right-click and select Paste. That's going to paste in the file address for the picture. After you do that, I want you to click on this button over here that hides the control bar, and then I want you to open up the AttackBox's browser. So the AttackBox browser has a Firefox browser. So the AttackBox has a Firefox browser. You can click on this button up here to start up the AttackBox Firefox browser. Okay, that's going to start up the web browser inside of the AttackBox, and I want you to click on the address bar, and then I want you to right click, and I want you to paste in the file address and hit enter. So what this does, it says that it, can I go over this again? Yeah, I'm going to have to go over this again because we need to do this pretty quick. Okay, so we're going to go over to task number 4. Task number 4, click on the download task files. And then I want you to quickly click on the address bar, select copy, and then click on the back button in your browser. And then inside of your AttackBox interface here, I want you to click on the button here. Click on the button here, click on the clipboard, click into the clipboard, paste in the file address, hide the clipboard, then in the AttackBox browser, highlight whatever is there already, and then select paste and go. And then you should be able to see the dinosaur picture inside of your web browser. If you manage to successfully see the dinosaur picture inside of your AttackBox web browser, please type in the chat, "I see the dinosaurs." Smiley face. So it's you do need to do it kind of quick because the file is going to expire in just a little bit. If for some reason you get the message that says that the file is expired, I want you to go and I want you to repeat the process again. Okay, so we see some people seeing the dinosaurs. That's great. If you don't see the dinosaurs, and are having trouble, please let me know. So let me demonstrate the process one more time for the people who might be having a little bit of trouble. So you want to go over to task 4 in the Try Hack Me page. You want to click on the download task files button. You want to click on this button. And then when you see the dinosaurs here, I want you to click into the address bar and highlight everything. Select copy. Then go back in the browser. AD says mine isn't working. AD, did your AttackBox load up eventually? So after you copy the file address, and go back, you want to click into the control panel, click on the clipboard, paste into the clipboard, then close the clipboard, go to your AttackBox Firefox browser, paste in the address, hit enter, and then you should be able to see the dinosaurs over here. AD says, it says failed to connect to server. Failed to connect to server. Which, does it say failed to connect to server on the right-hand side of the screen? Okay, so I want you to try reloading the page. Try reloading the page and see if that fixes the problem. If it doesn't fix the problem, then I want you to terminate the machine, and then try again. Okay, so to everybody else, what I want you to do now is I want you to save the file. So this is the image file we're going to be working with today. I want you to right-click on it and then select Save Image As. So right-click, Save Image As, and then I want you to click on the Save button over here. So you should see this little menu here. You just want to go down to the bottom right and click on Save. Okay. So after that, we're going to minimize our web browser. So the minimize button should be over here. So there's the X, there's the restore window button, and then the minimize window button. Oh, okay. So AD says, now it says non-subscribed users can only deploy the free attack box for 1 hour a day. Subscribe for unlimited access. Okay. AD, if you have another email address you can use, then you can make another account over at Try Hack Me, and then log in with that account and try to repeat the process. But otherwise, you could watch the class and then try again the next day. But if you want to do it right now, you can try using another email address to make another account over at Try Hack Me. Okay, so to everybody else, you want to click into the terminal over here in the attack box and hit enter. That's going to close out this window. And then after you do that, you want to click on the terminal icon over here. So double click the terminal icon, and that's going to start up a Linux terminal for the attack box. Okay, after you do that, I want you to move into the downloads directory. So move into the downloads directory by doing this command, cd downloads. And then after you do that, if you do the ls command to list out all of the files, there should be this file in the downloads directory. It's called extinction something something something.jpg. Okay, so let's see. Could you repeat the process after saving the image? All right, let me demonstrate that one more time. Let's see. AYD asks, can you go back and slow down a little bit? Oreo Byte is here in Twitch. Thank you for coming by, Oreo Byte. Hello, nice to see you here. I'm just teaching a little class. AYD says, can you go back and slow down a bit? So when you say go back, have you managed to, are you looking at the dinosaurs? So let me demonstrate what this looks like. So the dinosaurs are over here in the Firefox browser. So after you do that, and you see the dinosaurs, you want to right click on the image and select Save Image As. So right click, Save Image As, and then I want you to click on the Save button over here. So click on the Save button, and that's going to save the file. After you do that, you can minimize the Firefox browser, and then you can start up the terminal. So starting up the terminal is going to start up the Linux terminal that we can use. So you can double click the terminal icon over here. If you don't see the desktop, what I want you to do is I want you to click into the window that's there and then hit the enter key. And that's going to close that terminal window. After that, you can click on the terminal icon in the desktop. And what I want you to do then is I want you to do this command to go into the downloads directory. So it's cd space downloads. So type that in, hit enter. And then you should see this file in here. It's called extinction something something something.jpg. If you can see this file inside of your terminal, please type in the chat, I see the JPEG file. Smiley face. Okay, and if you can't see the JPEG file, let's see, user A says, after typing CD download, what do you do? So after you type CD download, well, it should be downloads with an S, and then you do the ls command to take a look at the contents of the directory. So just type ls and then enter, and you should see two files in here. So one of the files should be this one right here called extinction something 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 .jpg. So if you can see that, then you're at the right place. If you're having trouble, let us know, and we'll try to help you out. Okay, so from here, what we're going to do is we're going to try to get a hidden file out of this JPEG file, and we're going to do it with the steghide command. So steghide is the program that lets you do steganography, which is basically hiding files inside of other files. Let's see, user A says, I typed in ls and it gave me a bunch of different options. I typed in ls and it gave me a bunch of different options. That shouldn't be the case. So first you need to, user A, when you type pwd, it should say root downloads. If it doesn't say root downloads, let me know, okay? So the pwd command in Linux lets you know which directory you're in. It stands for print working directory, and it lets you know which directory you're working inside the Linux system. Okay, but for everybody else, so what we want to do is we want to inspect this file by using the steghide program. So the command we're going to give is, let's see, user ID says, I tried a whole new email and it says failed to connect to server. It says failed connect to server. AYD says, how do I type the orange coding? You don't need to type the orange coding. This is what we're going to do. So we're going to type in the name of the command we're going to use, and that's steghide. So steghide is the name of the program. After that, give a space, and then type in the word info, and then another space. So the last thing we're going to do is we're going to type out the name of the file over here. It's capital EX, but after you type the letters capital EX, we can autocomplete the name of the file by using the tab key on your keyboard. So the tab key is going to be on the left-hand side of the keyboard, and it's going to be underneath the escape key. So when you hit the tab key, it's going to autocomplete the name of the file, and then after you do that, I want you to hit enter. So the full command is steghide space info space extinction something something .jpg. AYD says, how do we get the file into the internal coding text box? Internal coding text box. So user A says, what do you do after EX? So this is, so after you type the letters EX, you can hit the tab key on your keyboard. So the tab key on the keyboard is going to be on the left-hand side, and it's going to be underneath the escape key. So, it's going to be underneath the escape key. Hit the tab key, and it's going to autocomplete the name of the file. After you do that, hit enter to give the command. User A says it didn't do anything. That's odd. So if the autocomplete doesn't work, you're going to have to type out the name of the file, and it's going to be a bit of a pain. extinction_1577976250757.jpg. So give this command. It's going to ask us, try to get information about embedded data. You're going to type Y for yes, and it's going to ask you for a passphrase. So there's no actual passphrase associated with this file, so you just need to hit the enter key. So it's going to say that there's an embedded file called finalmessage.txt. Okay, so AYD said, how do we get the file into the internal coding text box? I'm not sure what you're talking about. Are you talking about this window right here? Because this window right here is called the terminal. And did you download the file? Okay, let me demonstrate one more time. So we went to the Firefox browser and we managed to paste in the picture and access the picture. Then we did right click and save image as. So we clicked on save down here to save the file to the downloads directory. So after we did that, we clicked on the terminal shortcut over here. And then we moved into the downloads directory with this command, cd downloads. So make sure that the D is capitalized, and make sure that there's an S there. After that, if you do the ls command, you should see the ls command to list out the directory contents. You should see that there is an extinction.jpg file in here. Okay, so everybody, the next command after that is to use the steghide command. So steghide space info space ex. So you should be able to hit the tab key on your keyboard to autocomplete the name of the file, so you don't have to type out all these numbers. After you do all of that, hit enter. And it's going to say, try to get information about embedded data. You want to type Y for yes, and you want to hit enter when it asks you to enter the passphrase. So after that, you should see this message here that there's an embedded file called finalmessage.txt. If you manage to get this message here, please type into the chat, I see the message, smiley face. Okay, so the next thing we want to do, the passcode. So user Volcano asks, what was the passcode? There's no passcode, just hit the enter key and you should be able to see this. So when it says enter passphrase, hit enter. Okay, so the next step is to extract the message. So let's talk about this a little bit. So steghide, we're using this program to get hidden messages. So the first thing we did was we used the info command. If we use the steghide command with the info function, we can see if there are any embedded files in the media file. Okay. So this is steghide info and then the name of the file. And then we see there's an embedded file called finalmessage.txt. The next thing we're going to do is we're going to extract the file from this particular image. If we use the steghide command with the extract function, any embedded files will be extracted and copied to the current directory. So the command is going to be steghide space extract space -sf space and then the name of the file. So let's go ahead and do that in tryhackme. So tryhackme here, okay. So the command is going to be steghide one more time and then extract. Steghide extract space and then -sf. So this indicates what the stego file is. And in this case, the stego file is going to be ex. And then remember, you can hit tab to autocomplete the name of the file. And then after you've done that, you can hit enter. It's going to ask you to enter the passphrase. So there's no passphrase, you can just hit enter. And then it says wrote extracted data to finalmessage.txt. So after you've done this command and you type ls to list out the directory contents, you should see that there's a file called finalmessage.txt in the directory. So if you see that file in the directory, please type out final message smiley face in the chat. Okay, so what have we done so far? So we downloaded an image and then we tried to figure out if there was some sort of hidden information in the image by using the steghide info command over here. So we found that there is something in there. So we use steghide one more time to extract the information from the file. Okay, and the final thing we need to do is we need to read this message over here. So we can read the message in Linux by using this command cat. So it's cat and then the name of the file. So you can start typing out fin, which is the start of this file name, and then hit tab to autocomplete the file name. So after you do that, you can hit enter, and then you get this message here. It's going to be over soon. Sleep, my child. And then we get the flag. This is the objective of this. This is the objective of the exercise. So you know that something is a flag in cybersecurity when it's got some sort of little message at the front, and then it's got another thing inside these squiggly brackets over here. So what I want you to do is I want you to copy the content of the flag over here, and then right click and then copy. Then go over to the control panel. In the control panel, open up your clipboard, and you should see the flag content here. Dagger on YouTube says, waving hand. Hello, Dagger, nice to see you. Okay, and then you want to close the clipboard and then go over to task number 4. So in task number 4, it says, it is sad, feed me the flag. So just keep in mind this is task number 4. If it's not open, go ahead and click on task number 4, and that's going to open it up. So click in the in the submission field, and then paste in the flag, and then click on submit. Okay, so everybody, if you managed to get the flag and then copy it over to TryHackMe, please let us know by typing in flag submitted in chat. Okay? Okay, so everybody, there are ads running on Twitch right now, so I'm gonna play an ad on YouTube as well, and we're gonna take a little opportunity to have a little break. We're gonna have a little break while the ads run on YouTube and on Twitch. And in the meantime, I'm gonna show you some of my favorite birds. So this is one of my favorite birds over here. Oh, that's a really big guy. Hold on. Need to make the window smaller. Okay, so we're just going to take about a minute break, and yeah, enjoy the bird footage. I'm just going to have a little water break because I've been talking for a long time. So this is a bird that is resident to my area over here, and it loves peanuts. It loves peanuts. It loves shaking those peanuts around. And we're just going to put the birds away, and let's go on and continue with the lesson. All right. So I see that a few people have submitted their flag. To the people who didn't get to submit their flag, let us know what part of the lesson where you got stuck, and we'll try to go back and help you catch up, because we really don't want anybody to be left behind if we can help it. Jelena on YouTube says, "I love these birds. They're so cute." Yeah, they're very cute birds. I like them. I like them a lot. Okay, so if nobody needs any help, well, we're going to move on. So what we're going to do now is we're going to try to embed our own message into the file, and let me demonstrate how to do that. So let's try hiding a file. So we're going to use the current TryHackMe attack box terminal to embed a new file into the dinosaur picture file with steghide. So when we use steghide to embed a file into a picture file, we can break down the command like this. So there are a bunch of different parts to this command. We're going to go through this slowly just so we understand what's going on. So we're going to use steghide with the embed command. Then we're going to provide a file that's going to be embedded into, which is going to be the JPEG file. So this is going to be the extension file. And then we're going to give a passphrase. So we want this one to be more secure than the last one. And we need to specify a file that we're going to embed into the picture file. And we're going to create that file right now. Okay, so back in TryHackMe, let me make this a little bit bigger. Okay, hopefully you can read all this. What we're going to do is we're going to create a little file with this command right here. So it's going to be echo and then some double quotes. So inside the double quotes, we're going to leave a little message. And the message is going to be, the secret is HackerFrogs rule, exclamation point. Okay, and we're going to go ahead and we're going to redirect this and make a little file called secret.txt. So if you're wondering what the command looks like, I'm going to paste it in the chat. Just so you can see what this command looks like. So remember, when we give this command, we need to use this greater than sign over here. So the greater than sign is going to be the shifted version of the period, and after you do that, you're going to see a file called secret.txt has appeared in the directory when you do the ls command. Okay, so after that, we're going to give the command that embeds the file. So the command is going to be steghide space embed space, and then it's going to be -cf, and cf is the cover file. So the cover file is going to be the picture file that we're going to embed into, and it's the extension.jpg file. Remember, you can type in the first two letters and then hit tab to autocomplete the name of the file. So after that, we're going to give, let's see, what is okay. So EF is going to be the name of the file that we're going to embed. So embed file -ef with secret.txt. So -ef secret.txt. And the last thing we need to do is we need to set a password for this. So the password, or -p, that's going to be password 123. Okay, so this is what the command looks like in its entirety. And you should see that when we give the when we inspect this with steghide again, steghide info, it's going to ask us try to get information about the embedded data. We press Y for yes. We're going to need to put in our passphrase now. So the passphrase is what we set right over here, password 123. So type in password 123 and hit enter. And then it should say embedded file secret.txt. So if you manage to get this far and you get this information, embedded file secret.txt, let us know in the chat by typing in it's a secret, smiley face. If you're having trouble, let us know. Let's see. AYD says it won't allow me to put in the greater than symbol. Okay, so the greater than symbol is shift and then period. So usually it's the period. If you press shift and then press period, it should show the greater than symbol over here. If you're still having trouble, let us know. So if you ever find that your terminal is a little bit too crowded, you can type in the word clear and then hit enter, and that's going to clear the screen and bring you back up to the top of the terminal. So it shows up as a period. That's strange. So the shift key on your keyboard works, right? Oh, okay. It works now? Yeah? That's great. All right, so go ahead and try this. So the command is going to be this one over here. Remember, if you can press up and down in the terminal, and that's going to get your previous commands. So this is called the terminal history. And the command we use to create the secret.txt file, so it's echo the secret is HackerFrogs. Rule exclamation point between these between these double quotes over here. If you don't do the double quotes, it's not going to work. And then do space greater than secret.txt. Okay, and the last thing we do is we're going to extract the secret.txt file again. So before we extract the secret.txt file, we need to delete this secret.txt file. So to delete a file inside of Linux, we do the rm command for remove, and then space secret.txt. After you do that, when you do the ls command, you should see that the secret.txt file is no longer there. Okay, so we're going to extract the file like we did in the previous exercise. So it's going to be steghide space extract space, and then sf space, and then ex, hit the tab key, ta to complete. Hit enter, and it's going to ask you for the passphrase. Remember, the passphrase we set was password123 with a capital P. So capital P, ASSWORD 123, hit enter, and you should see this message here, wrote extracted data to secret.txt. So if you see this message after giving this command, let us know in the chat. Type in I extracted smiley face. Okay. User A asks, what is the passphrase? So in the previous command, we used this command to embed into, where is it? This command here. We set a password. So we did -p space and then password123. That's the passphrase. The passphrase is capital P ASSWORD 123. Okay, so if you're having trouble during today's exercise, please let me know, because I'm trying to help everybody get to the same place. Okay, so everybody, if you manage to extract the secret.txt file, you can go ahead and read it. So just do the cat command, cat secret.txt. You should see the message that we wrote into the secret.txt file. The secret is HackerFrogs rule. Okay? And if you manage to do all of this stuff, let us know by typing in I did all the stuff. Smiley face. Okay, and if you got stuck at some point, AYD says it won't allow me to type the passphrase. So you're doing this right now, right? So you did the steghide extract -sf extinction something something. When you type in the passphrase, you're not going to see anything. So I'm typing in the passphrase. You don't see anything. This is normal. So just type in the passphrase anyways and hit enter. So when you type in the passphrase, you won't see anything appear. Just type in PASSWRD123. Nothing appears on the screen. This is normal. Just type it in and hit enter. And it should say wrote extracted data to secret.txt. No worries, no worries. This is something that happens in Linux. In Linux, when you're typing in passwords, you usually don't see anything appear. So you don't see the letters appear on screen as you type them, but this is to keep it secret from people who might be watching, because they might be able to tell something about your password if they see it's a long password or a short password. Okay, so let's go ahead and talk about what we learned in today's lesson, and then we'll finish the lesson, okay? So I think it was, let's see, which user was having trouble with, okay, user AD, right, was having trouble with their attack box. It said failed to connect to server. Also said that non-subscribed users, I'm really sorry that happened, but you should be able to try again like tomorrow, and maybe we can you can watch the lesson again and try out all the stuff that we did today. But let's review what we learned in today's lesson before we finish out today. Okay, so today we learned about steganography. So steganography is the process of hiding information in another medium. So for example, we hide a hidden message in a picture, or we embed pictures. We embed stuff in pictures. Mr. Dieseldug says, steganography is very cool. Briefly touched it in college. Oh, great, great. Nice to see you here on YouTube chat, Mr. Dieseldub. And HoDZ says, good job. Good jab. Thank you, thank you. Anyways, what else? So when dealing with digital files, steganography can be used to embed files or messages into different media files like pictures, videos, or audio files. Okay, so steghide. We talked a little bit about the steghide program, and the steghide program can be used to do steganography stuff with different media types, so pictures and audio files. And embedding files with steghide can use password protection for added security. So most of the time when we do these steganography challenges, there's going to be a password that we have to put in order to access the stuff that's been embedded with steghide. So what's next? So in the next digital forensics workshop, we're going to introduce network traffic analysis with the TriAcne platform. So this is a really big part of digital forensics. It's looking through network traffic. We'll talk a little bit about how network traffic works and how it moves around, and we'll also be talking about the programs that we use to the program that we use to take a look at these network packet capture files, and that's going to be in the next class. Okay, so for everybody on YouTube and Twitch, we're going to be taking a little bit of a break before we move to the next part of the stream, because I need to end the section of the stream with, we need to end the lesson with the students on Zoom. So I'm also streaming on Zoom, and I'm teaching a little class. We'll be back in about, I'm going to say something like 5 to 8 minutes, and then we'll start the next part of the stream then. But until then, we're going to be doing a little be right back screen. We'll be back in a few minutes, and please enjoy the music and enjoy the be right back screen. Okay, so it's just us Zoom people now. Okay, so everybody, If you managed to finish the exercise, let us know by typing in the chat that you managed to finish the exercise. If you got stuck, also let us know that you got stuck, because, you know, I want everybody to be able to finish these exercises. Okay, so we see some volcano finished. AD got stuck but figured it out. Okay, I know some of the students, they got stuck with some technical difficulties. Okay. Aisha says, let's see, I got stuck a bit. Aisha, did you manage to finish the exercise, or did you, which if you didn't manage to finish the exercise, which step did you get stuck on? Tornado Siren says, I can review. Didn't finish yet. Okay. Let us know what step you got stuck on. Tornado Siren says, I can review. All right, that's great. And I got stuck at the password part. Yeah, so when you type in the password, you won't see anything appear on the screen when you're typing it in. So you just need to type in the password even though you can't see anything on the screen, and hit the enter key. And you should be able to put in the password that way. But yeah, everybody, we're going to be back on Monday. So on Monday, we're going to be doing our next class. It's going to be at the same time. And we're also going to be setting up a little forum where we can leave messages and I can do announcements and stuff. So that should be online by Monday or so. Monday is going to be the next class at the same time, like I said. And yeah, thank you very much for everybody to come to today's class. So have a great weekend, and you're free to leave the call now, but if you have any questions or comments or anything, then you can leave them in chat right now. But otherwise, have a great weekend, and we'll see you on Monday. Okay, no worries. Yeah, so have a great weekend, AD, and we'll see you next time. Okay, so, alright, we're going to be starting the next part of the stream now. Let's go ahead and get ready for that. So what are we doing today? Oh, let's play some different music. Let's see. So yeah, we've got a bunch of people on YouTube chat right now. We got HoDZ, and we got Jelena, and we got Mr. Diesel Doug. Let's go ahead and make the chat nice and big for me. Okay. So what are we doing in the next part of today's stream? So in the next part of today's stream, we're going to be going over to Codecademy. The Pajaro 88, hello, nice to see you there. And welcome to the stream, Pajaro. Let's go ahead and give a fun video redeem. Haven't done one of these in a while. This one's going to be Hack the Planet, because that's what we do.
Hack the planet! Hack the planet! Shut up and get it.
Okay, so if you want to join in along with this lesson, you're going to need an account over at codecademy.com. Codecademy is a very good place for learning about different programming languages, and this is the link for the website in general. The class that we're going to be doing today is we're going to be learning about functions in the C programming language. So C is a very popular language. It's pretty old, and for the most part, a lot of people there are not so many people who are coding in pure C. They're usually using the derivative program called C++. But we're learning about C, the C programming language, because what we want to do is we want to learn about insecure functions that can be used to create vulnerable programs using the C programming language. So to do that, we're just going to be doing a kind of high-level overview on how we program using C. So let's go ahead and start this little lesson. And if you're following along with us, let us know in the chat, because I like to know who's who's following along and having fun and coding along with us. So let's go ahead and put on some music for this portion of the stream. How about some moody music from Dungeon of the Endless? It's a fun little sci-fi game. I love all my sci-fi games. They usually have really good soundtracks. As usual, if you think that the music is too loud, let us know in the chat so that I can turn down the music a little bit. It's a bit loud. Okay. GX00 says, I'm having fun. Well, that's great. I'm glad to hear that you're having fun, GX000. All right, let's go ahead and learn about some programming language here. So this is C. So we've done some other programs learning about C programming in the last few weeks, but now we're talking about some important stuff, and we're talking about functions today. C what? C the programming language. The C programming language. As you continue to write more code, there will be times when... Thank you very much for following on Twitch. Eli Ornco? Please let me know how to pronounce your name. Thank you. Thank you very much for following on Twitch. Okay, as you continue to write more code, there will be times when you need to reuse a set of instructions. You might be tempted to reuse the code by copying and pasting it, but in times like these, a function is a great tool to use. So what are these programming functions? A function is a group of instructions that is given a name to be used elsewhere in the code. Often repeatedly, functions can take in a set of inputs and produce some output. So we've got this make cookie function over here. We put in a bunch of stuff, we run the function, and we create a cookie. Awesome. Okay, so in the photo above, we use the idea of a function to make cookies. We collect a set of instructions, which is the recipe, under a name, make cookie. Baking a cookie requires a set of inputs, or the ingredients. The instructions inside the function act on the input ingredients to produce the output, a cookie. Functions are great because you can write dry, and dry means don't repeat yourself code. Harry Bus on Twitch says, have you used or heard of Pwn College? I think Pwn College is a great platform for learning about cybersecurity stuff, especially learning about reverse engineering and binary hacking. But unfortunately, Pwn College doesn't want any of their stuff to be in videos or on streams. So I haven't showcased any of their stuff on my live stream because they don't allow it. But Harry Bus, yes, I know about Pwn College. It's a great place to learn about cybersecurity. Okay, so what else is great about functions? You can execute any number of instructions within a single line of code. Yeah, okay. And once a function exists, you only need to worry about the inputs and output, and not about the instructions inside. So Harry Bus, are you a cybersecurity student? Are you working in the industry? Let us know, because we really appreciate all the students and the professionals participating in the stream. So in C, once you've worked with one function, in C you've already worked with one function. So we've actually worked with a few different functions in C already, and the main function is basically the thing that any program is going to run. We also use functions inside of the main function, such as the printf function. Let's see, Zani, hello, nice to see you here on Twitch, Zani. And Harry Bus says, I'm pretty new, did some try hack me and a few PicoCTF problems. Well, we're glad to see you here, Harry Bus, and if you want to learn about cybersecurity, PicoCTF is probably the place you want to start, and afterwards go over to, well, maybe PicoCTF and try hack me. They're pretty good places for beginners. Hack the Box and Pwn College, they're not as they're great. Don't get me wrong, but they're not great for people who are just starting out. But yeah, if you think you're ready for Hack the Box or Pwn College, then by all means do so. Okay, so what were we doing? We're going to look at the main function in the script.c file. There are two lines. one that calls a function, which is abs. Abs stands for absolute, I think. And then the printf function to output the value in abs value. Okay. Run the program to see the output and think about all the things happening in the code that we can't see. This is good. This is a good example of dry, or don't repeat yourself, coding in the C programming language. Okay, so what is this doing? This is the main function here. Zani asks, are you fluent in C? I am not fluent in C. I've been teaching myself C, and I've been trying to introduce it to everybody here because, well, we do a lot of binary hacking and reverse engineering on programs that are written in C. And if we're going to be doing this, we should understand what exactly is going on inside the code, even if we're not completely fluent in that programming language. So when we do hacking, of course, it's the most ideal if we're only dealing with stuff that we are experts in. The problem is that there are too many things to be experts in everything. So sometimes you're going to have to make do with the amount of knowledge you know, but we're always trying to improve and add to the amount of stuff that we know about, the technologies and the programming languages and all that stuff. Thank you for following HarryBus421. Thank you. And you know what? Let's give you a fun little video redeem. How about a Nyan Cat just for you? Okay, so what's going on inside this main function here? So the main function, we're going to define this variable here. It's called abs value. It's an integer. And it's going to be equal to a function. And the function is, let's see. Oh, HarryBus has subscribed with Twitch Prime. Wow, thank you very much. Thank you very much for following with for subscribing with Twitch Prime. That's a great help. And we got ads running on Twitch as well. And I guess HarryBus isn't seeing the ads because they had just subscribed. In return for the knowledge and Nyan Cat, I shall sub. Thank you, thank you. Okay, so we got an ad running on Twitch right now. We'll also run an ad on YouTube, and we're going to put on some birds. How about these birds? So these are the Stellar Jays again. I've got a lot of videos of these Stellar Jays, and they're easily my favorite birds. Okay, so enjoy the birds and the music, and I'm just gonna have a little water break. So just a second. So GX00 says, what is this magic? Do you control the ads? I don't control the ads. I control how often they appear. And they appear for 90 seconds every half hour or so. And I think that's the minimum. Well, okay, it's pretty close to the minimum amount that you can set for the ads on Twitch. Unfortunately, I can't turn the ads off completely. But you know what? The ads are actually not so bad for me because I need to take a water break every once in a while. Anyways, let's go ahead and put the birds away and let's continue on with the lesson. So the abs function is going to give the absolute value of whatever is given to it. And in this case, it's given the number -5. So absolute value is going to be the positive version of whatever number it is. And abs means that -5 is going to have an absolute value of 5. So when we print this, when we run this function, or we run the program rather, then we get 5, because we're printing out the abs value, which is equal to abs run with -5. That's going to give you 5. Okay, let's move on to the next part. So the next part is calling a function. So as we've seen, the code printf hello world outputs the string between the parentheses to the console. The general usage of the function is to call the given name with a set of parentheses. Any input that is needed for the function to be done is placed inside the parentheses. These inputs are commonly known as the arguments of the function. Certain functions take no arguments. Some take one and some take multiple. No matter the case, it is important to know what arguments a function expects so that we can use the correct values in the correct spots. The printf function can change its behavior based on the number of arguments it receives. So okay, we've got an example here. We got printf hello world, and then we can do printf with a string and then a symbol over here and then the name of a variable. GX00 says, I hate arguments that fight. Yeah, I understand. So GX000, are you at home right now, or are you at work, or are you somewhere else? Let us know. GX000 is a member of the local cybersecurity community over here in wherever I live, and if you figured that out, then congratulations, you know. Okay, so in the example above, the first printf call takes the string hello world as an argument. This is the output. The output is the string. The second printf statement takes two arguments, a string and a variable. The output this time is the string with the variable inserted where indicated by the %d. These two uses of printf show the flexibility that is allowed by when using functions. Lastly, a function can return its output, which can then be used further. For example, something like this. GX000 says, I work from home, but I'm basically done for the day, getting ready and packing for vacation. Oh, huh. Are you okay sharing where you're going on vacation on the stream? If not, let us know, then we will respect your wishes, of course. Okay, so we got this C program over here. So we got the integer absolute value, abs value equals abs minus 5, printf absolute value of minus 5, and then %d, and then abs value. So output is going to be absolute value of minus 5 is 5. Okay. GX000 says, 1 day in Paris, 3 days in London, like 2-week road trip. 2-week road trip in Scotland. Something tells me you are a lot more attached to Scotland than you are to those other locations. Okay, so in the above example, we use a different function, abs, which returns the absolute value of an integer passed as an argument. We're able to use this function by adding the line include standard library h to the top of the code. As we can see, when we call abs minus 5, we are assigning it to the integer abs value. This assigns the value returned by abs minus 5 to the variable abs value. This is shown by outputting the value, which is 5. GX000 says, I am Scotland is a bucket list location. I hear it's a beautiful country. Okay, so we got some instructions. Let's take a look at the different functions, the different function argument configurations of printf. In script.c, add a call to printf with no arguments. You should get an error when you call printf with no arguments. Okay, so let's go ahead and do that. So inside the script.c, we're going to give a printf statement with no arguments. So any function is going to have a pair of parentheses, and inside the parentheses are any of the arguments we need to run this particular function. So when we run this, it's going to give us an error message. And the error message is going to be in function main, too few arguments to function printf. So the error messages will tell you, they should tell you exactly what is going wrong, so you can do some debugging. Okay, so the next step here says, now add a string of your choice to the arguments of printf. Does the code work now? So let's go ahead and go back to the printf function here. We're going to give something to print. So HackerFrogs rule, okay. And then let's run the function again. Okay, and we get our output and we get our printed string over here. Great. Okay, so the next step, now add a value in the variable num1 to the output. Be sure to add the variable as an argument and adjust your string to support the variable output. So we're supposed to add num1 to the output. So num1 is going to be this integer, and the integer is equal to -5. So what we can do to include this, we're going to adjust our print statement a little bit. So the HackerFrogs number is %d. So %d is for, I think it's for digits. I'm not too sure what the d stands for, but this is what we use when we're inserting integers into strings. So in this case, after the string, we're going to do a comma, and then we're going to include the name of the variable, and the variable name is num1. Num1. Okay, let's go ahead and run this. It should give us the message, the HackerFrogs number is -5. Let's run it. Okay, great, it worked. Okay, so the last thing we need to do is this. Decimal integer. Okay, great. I'm glad to be educated. Thank you, GX000. So can we add a variable to the output? Let's give it a try. Add the variable num2 as the third argument and adjust the string to output the values in both variables. So what do we need to do here, as opposed to a float or something? I think floats in C are %f for float, so that makes sense. Okay, so let's see. We're going to add num2 to our output as well. And the way we do that is we're going to do the HackerFrogs number is %d and %d, because we're going to be including two numbers. After num1, we're going to give another comma, and we're going to put in the second variable, which is num2. Okay, so after that, we should get the HackerFrogs number is -5 and 42. So let's go ahead and run it. Okay, and it works. So this is how we use the printf statement and include multiple variables. Multiple parameters in here. So let's go ahead and go on to the next section. So what are we talking about here? We're talking about library functions. So now that we know how to call functions, use their arguments, and capture their return values, let's take a look at some functions provided by the C programming language. C gives us access to many useful libraries that include many different functions for you to use. In order to have access to these functions, you need to include header files like standardio.h and standardlibrary.h. You have already used printf to output text to the console and learned about the abs function to find the absolute value of an integer. Here are some more functions that you might use in your programs. So we got seal for sealing, takes any number as an argument and rounds it to the nearest integer and returns that integer. Okay. We got log, takes an integer as an argument and returns the natural logarithm of that given number. We've got toUpper, takes a character as an argument and returns the uppercase of any alphabetic character. And isUpper, takes a character as an argument and returns 1 if the character is an uppercase letter and 0 otherwise. So let's use these functions in some code. Okay, so what do we got going on in this code over here? So we got a float variable called number, and it's 4.5. We've got a character variable called letter, and it's equal to lowercase a. And we're going to printf the ceiling of number. So ceiling of number is going to be the float number here. I think what ceiling does is that it chops off whatever comes after the decimal over here, and it only returns the integer. So if you run ceiling on 4.5, it should return 4. Does it round? Let me look it up really quick. It rounds it to the nearest integer. Oh, rounds it up to the nearest integer. Okay. So it doesn't chop off the, it doesn't chop it off. It's going to round up. So 4.5 is going to become 5. So anything 5 or up is going to round up, and anything below 5 is going to be rounded down. That's what I think is going to happen. So yeah, it does round it up to 5 because we see it over here in the comments. Okay, we got the log of the number. So the log of... So I'm not all that great at math. So it says, takes an integer as an argument and returns the natural logarithm. So I'm not exactly sure what a logarithm is. I could probably find out really quick. Maybe I should do that. What is the logarithm of a number? Ask GPT, of course. Well, the AI answers the question. So it's the inverse operation of exponentiation. It's the power of which a base number must be raised to get another number. So for example, the logarithm of 10 to the base of 10 is 2, because 10 raised to the power of 2 equals 100. Oh, okay, so it's the inverse of the exponent. This is not something I really dealt with in my math classes. Anyways, let's go back. Okay, the letter variable is passed to the isUpper and output. The result is going to be 0, which represents false. Okay, so this is the letter A. We're going to check if it's an uppercase letter, and it's going to return 0. And the last thing is upper. No, that's the last one. Okay. So there are many useful functions contained in the C standard libraries. Here's a list of them. We're not going to go through that. It is worth looking through them to see how they can help your code. Okay, so in the instructions we got. Now let's look at some libraries and their functions to create some random numbers. So in script.c there are 3 include statements. So the first one is needed for printf. So this is the standard library that includes printf. And we got standardlib.h, which is needed for 2 random number generators, srand and rand. And we've got the last one, time.h. This is needed to use the time function. So inside the main function is the line srand time null. Without this line of code, every random number generated in this exercise will be the same number each time you run the code. Look in the hint for more details on this line of code. Move to the next exercise to continue with the random number code. Okay, so all we need to do now is we need to click on Run, and then we can move on to the next section. So with the random number generator initialized, it is time to get a random number. This is done by saving the return value of the function rand. Okay, so inside the main function, declare an integer value random number and set it to be equal to rand. Okay, so main function, hold on, I think I need to reset my code. Okay. So declare an integer value random number. So integer random number and set it to equal to rand. So rand. Okay, let's go ahead and run this. If you run the code multiple times, you should get a large but somewhat different number each time. Did you use printf to output the random number? No, we did not. So let's go ahead and do that. Okay, so we need to print this. So printf, we're going to printf the random number. So the random number is going to be an integer, so we need to use this. So it's going to be %d, and we're going to set the integer to random number. Okay, and then we're going to run this. and we get a big number. When we run it again, we get more big numbers, but different big numbers. Okay, what's next? So if you run the code multiple times, you should get a large but somewhat different number each time. Number 3. So this is the third step of this exercise. There's a good chance if you were programming a game that wanted to roll some dice, the number being generated right now would not be helpful in its current form. To get the number we want, we will need to use the modulus operator. So this random number, we're going to be dividing it by, we're going to be modulus. What is the term? We're going to be running the modulo operation on it to get a smaller number. And this is how we're going to do it. So inside the main function, using modulus or modulo, change the line of code int random number equals rand so that the random number will be between 0 and 19. Okay, so 0 and 19 is 20 numbers. So we need to modulo by 20. So int equals random number modulo 20. So whatever result we get from random number, we're going to divide it, we're going to modulo it by 20 and get a much smaller number. It also says add a +1 to the end of the code so that random number becomes a number between 1 and 20. So right now, it's going to give us a number between 0 and 19. We're going to just add 1 so we always get a positive number. So that's going to be modulo 20 plus 1. Okay, so every time you run the code, you should get a number between 1 and 20. Let's go ahead and run this. We get 4, we get 11, 17, 14, 17, 6, 2. Okay, so it seems to be running correctly. Let's move on to the next part. Okay, so now we actually get to write some of our own functions. So we've seen how C comes with many handy libraries full of functions for us to use. Now let's learn how to make our own. So to begin, we're going to need the function signature. So the function signature tells us 3 things. The function name, how many parameters or inputs and their types, and what type of return value is to be expected. Okay, so return type, function name, type 1 parameter 1, type 2 parameter 2. Conrado Fix, hello, nice to see you here. Let's give you a fun video redeem. How about a Hack the Planet? Nice to see you here.
Hack the planet! Hack the planet! Shut up again!
Okay, so it says if a function isn't going to return any value, void is used as the return type. Void indicates to the compiler that the function returns no data and should not expect to see the return keyword. Any of the types covered in the previous lessons, such as int, char, boolean, etc., can be used as the return type of a function. Similarly, if a function has no parameters, void should be used in the place of any parameters. The parameters listed inside the parameters are like the variable declarations. Each parameter should start with the type and the name of the parameter. Okay. So the code statements inside of the function are known as the body of the function, are enclosed with curly braces after the function signature. So what do we have here? So the return type, then the function name, then inside of the parentheses here, there's going to be type 1, parameter 1, type 2, parameter 2. Of course, we don't need to have any of these if we don't want to. We can just have it void if we want to. And then inside the curly braces, we've got our statements and then return if it's designed to return. They're not all designed to return. The signature and the body are 2 parts we need to create our own functions. So for example, we got this sample function here. So this is called void make cookie. So void means that the function doesn't return anything. And then we've got the make cookie function, which does the following. So this does a bunch of printf functions. So printf, and then a bunch of ingredients for making cookies. And then it says, thanks for the ingredients, here's a cookie. And then we have the closing curly brace. Okay, so it's time to create your first function. So above the main function, define a new function named printMyFavoriteAnimal. Okay, so define a new function named printMyFavoriteAnimal. So the function returns no value. So this is going to be a void function. So void means we don't return anything, and then we give the name of the function. So print my favorite animal, and then we give the parentheses, and then we give the curly braces. It says the function has no parameters. Okay, so that means that inside of the parameters here, we also type the word void. So void is the type of data that's returned, and inside the parentheses, void is the type of parameters. So because there are no parameters for this function. Leave the body of the function empty for now. Okay, that's great. Let's run. And then the next part. So number 2, inside the body of the function, output the message, my favorite animal is your animal name. Okay, and then we've got this. So whenever we have the opportunity to do copy paste, we should do copy paste. So let's go ahead and grab all this and copy, and then paste into our function here. So paste that in. Paste that in. My favorite animal is your animal name. So I guess instead of your animal name, my favorite animal is a HackerFrog. Okay. So this completes the function, so move on to call your first complete function. Okay. I guess we can run this. Oh, you know what? There's something wrong with this statement here. The statement doesn't have a semicolon. So it says expected declaration or statement at the end of the input. This right here. So declaration or statement, this is not a statement. There's not a statement until we put in the semicolon. Okay, let's run it again. Oh, wait, no. Sorry. I'm not thinking enough. So this is supposed to be a printf statement. So the printf is going to be my favorite animal is HackerFrog, and between the parentheses. Okay. Let's run it again. Wow, I'm not doing very well today. So printf, my favorite animal is a HackerFrog. Oh, you know what? It's the type of quotes here. The quotes that I copy pasted are not the right type of quotes. So the quotes that we use are very important. If we use the wrong type of quotes, these double quotes here, they're not the same as these straight up and down double quotes. Yeah. Now it works. It works because we I tried to use copy paste, but copy paste didn't work. Okay, so the last thing we need to do inside the main function, call the printMyFavoriteAnimal function. So how do we call functions? All we need to do is go into the main function here and then give the name of the function. So printMyFavoriteAnimal, and then parentheses, and then semicolon. So when we run this, it's going to call this function. So by calling a function, we're running a function, and it's going to do this printf statement here. Okay, great. It worked. Let's move on. Okay, so function return values. We now know how to define a function, so let's take a closer look at function return values. Calling a function to do some work and returning a value is a common use of functions. So it's important to understand how to define what type of value is returned to ensure that it is returned. So many of the C types that we've seen so far can be used as a function return type, like int, double, char, and even pointers. So we've got, let's see. We got getSecretNumber. This is a function that returns an integer. and it looks like there are no parameters. So all this does is it defines the secret number variable as the number 7, and then it returns that secret number, which is the number 7. In the example above, the function has a return type, which is the integer, okay? The variable secret number of type integer is set to 7. The variable is returned using the return secret number. So the type of value returned inside the function must match the type defined in the function signature. If there is a mismatch, you will get a compilation error telling you of this mismatch. Once the return statement is executed, the function gives control back to the function that called it, and no further code within the function will be executed. For example, if we've got this function here, we create secret number, we return secret number, and then for some reason there's this extra printf statement. The problem here is that after we do the return statement, then the function ends. So that means that this printf statement will never run. The printf statement will not execute, and don't tell anyone will not be displayed in the output terminal. Okay, so we got more instructions. Continuing with the random number generation, modify a function definition so that it can return a random number from 1 to 1000. The function getRandom1000 currently has the return type of void. Change the return type so that the function can return an integer. Okay, so what we need to do here in getRandom1000, we need to change the return type from void to int. Okay, and then run. Okay, now we've got number 2. Alright, we got ads running on Twitch. When ads run on Twitch, we run them on YouTube. And let's go ahead and put on some birds while I take a little water break. So let's see, how about this cute little bird? Alright, please enjoy the music and the bird. We will be back in about a minute or so. So this is a northern flicker woodpecker, and it's one of the most beautiful woodpeckers you're going to see in North America. I mean, I guess I'm biased because they're around here, but yeah. And another interesting thing about the northern flicker woodpecker is that their main diet consists of ants. So you're going to see them on the ground a lot, digging up little ant hills. You'll occasionally see them breaking up cow patties to get insects inside. So that's kind of gnarly, but they do what they need to do to get the bugs. Okay, let's go ahead and put the birds away. Go back to the lesson. Okay, so number 2. Now at the end of the getRandom1000 body here, we need to return the variable random1000. So what's actually going on inside this code? So we got integer random1000. It's going to be equal to the random1000 function modulo 1000 plus 1. Okay? We need to return the variable random1000. So I guess what we're going to do is just type in return random1000 and then semicolon. I think that's all we need to do. Let's run this. Okay. And it says here in number 3, lastly in the main function, replace the 0 with the call getRandom1000 and store the return value inside the variable random number. Okay, so let's see. We got the main function here. Int randNumber equals 0. We need to replace this with a call to getRandom1000. store the return value in the variable random number. So this is all we need to do, I think. Okay, let's run this. All right, let's move on to the next section. Okay, next we're going to be talking about function parameters. So in the last exercise, we created a function random1000 that returned a random number between 1 and 1000. What if we wanted the upper bound to be 10,000 or 100,000? We could define new functions like getRandom 10,000 or getRandom 100,000. There must be a better way. Besides returning values, functions can customize their behavior based on the arguments passed to them. This is done by defining parameters in the function signature. Parameters are variable definitions that take place in between the parentheses of the function signature. They have a type and are given a number to be used inside and only inside the function body. Let's take a look. Okay, so what do we have here? So we have a function called add2. So add2 returns an integer. And the parameters for this add2 function are an integer called random1 and an integer named random2. So inside of the function, they're going to define sum. So sum is also an integer, and it's going to be equal to number 1 plus number 2. And the return value is going to be the sum. Okay, so in the example above, the add2 function is defined with an integer return type. The function takes two integer parameters, number 1 and number 2, to be used inside the function body, and the function adds the numbers together and assigns them to an integer sum and returns sum. So one thing to keep in mind, if the parameter type and the argument passed to a function do not match, a warning or an error will occur when we run the code. Okay, so we've got, what do we have here? We've got sayIt, which returns nothing, and it takes in an integer named number, and it prints that number. So inside of the main function, what's going on? So we're going to define a string, and it's called hi. So I think this is a pointer, according to the asterisk over here. But yeah, then we run the sayIt function with the string. So this isn't going to work because it says that it's supposed to take in an integer. So the code above will produce a warning that the sayIt function argument type, char, and the parameter type, int, are not the same. This will result in unwanted behavior. So the last thing to note about parameters is if a function does not have any parameters, you should put void in between the parentheses. Leaving them empty will usually be okay, but it is best practice to use the word void. Okay, so number 1, the getRandom1000 function has been changed to getRandomNumber. Modify the remaining part of the function definition. Okay, so the first thing we need to do is add an integer parameter called maxNumber. So we've got getRandomNumber, add an integer parameter maxNumber. getRandomNumber. Okay, so let's go ahead and add an integer parameter named... Oh, we're adding a parameter, never mind. Okay, so the parameter is over here. So here, this is where we put in the parameters. And it's going to be an integer named maxNumber. Okay. So number 2, inside the getRandomNumber body, use the parameter to set the range. Use the parameter to set the range. Replace the upper range number in the random equation with maxNumber. Replace the upper range number in the random equation. So let's see. So it's going to be int random number rand modulo maxNumber. So we're just going to replace 1000 with max number. Okay. And number 3, now test the new function out. Inside the main function, assign random number to getRandomNumber with the argument 100. So we're here, and let's see, int random number 0. So it's not going to be random number 0, it's going to be int random number equals get random number with the parameter 100. Okay, so let's go ahead and run the code. So you can now generate random numbers between 1 and any number you want. Good job. So run this. My random number is 74. Great. My random number is 12. My random number is 100. Oh, that's funny. Okay, let's move on to the next section. Okay, so this is a tricky little part. So functions with pointers. So you've made great progress so far with the functions. Up to this point, when a function has received an argument, the function makes a copy of the argument's value and stores it in the parameter value. Now any work that the function does on that parameter value, that parameter variable will not affect the original value passed in. So for example, we got this. So my function with an integer called a is going to be equal to a plus 2. How does this work? A equals a plus 2. Printf a inside my function with a. A inside my function, a. Okay? I guess that's going to print whatever a is plus 2. In the main function, integer a is going to be equal to 10, and then we run the function a. So a is going to be 10. So print a in main, something something a, something something a. And because, oh, thank you very much for following. Msalah O. Thank you very much for following on Twitch. Let's give you a fun video redeem. How about you get to hack the planet as well? Oh, that's spelled incorrectly. Let's try that again. There you go.
Hack the planet! Hack the planet! Shut up again!
So let's see, a inside my function should be... Okay, so this should print out the number... So normally this is going to be whatever the a is plus 2. So if we define a as 10 in here, this should print out 12. So it says a inside my function is 12, a in main is 10. That's interesting. Weird Fox, hello, nice to see you here on YouTube, and welcome. Why don't you have a Nan cat? There you go. Okay, so it says this is great because we can safely alter the variable value inside the function while maintaining the original value outside. So what if we want to alter the variable inside the function? Instead of passing the actual variable as an argument, we can pass a pointer to the variable. Remember, a pointer is a variable that holds the memory address of another variable. The memory address tells you where the original variable is in memory. Before we pass a pointer to a function, we need to make sure that the parameter type matches the type of pointer we are passing. With a pointer as a parameter, the body of the function can directly alter the original value of the pointer that it was passed. Okay, so this time we're going to be including some pointers. So my function, this is the same function as the previous example, except that the integer is going to be a pointer. So integer pointer a, the pointer a is going to be equal to pointer a plus 2. Weird Fox says, I'm going through a Python course. You told me that's available on Skills for All. Oh, you're going through the Python course on Skills for All. I hope you're having fun, because, yeah, that course is very, very in-depth. And considering it's free, it's pretty good. It's pretty good the last time I took a look at it. Okay, so let's see. So inside the main function here, a is going to be equal to 10, but we're going to do integer pointer. A pointer is going to be equal to a. Okay, so my function a pointer printf a in main is equal to this. So a inside the function is going to be 12, and a in main is also going to be 12. So a benefit to using a pointer to a variable as opposed to the variable itself is that it saves memory, as the function does not need to allocate more memory for complex data types like arrays. So let's look at how we can change values in functions using pointers. Okay, let me reset this. So above the main function, define a function named increment age that returns no value. Weird Fox says, I would like to make a cybersecurity tool in Python. For my last year assignment in uni, I hope I will be able to understand programming. Yeah, I think if you spend enough time playing around with programming, you're taking a look at Python. Python is a much more forgiving programming language than C is. I'm sure you'll have an all right time as long as you spend enough time playing around with the programming language. Okay, so what are we doing in the main function? So define a function named increment age that returns no value. Okay, so this is going to be void increment age that returns no value. Okay, so what's happening in here? The function should have one parameter, an integer pointer, age pointer. Okay, so it's an integer pointer. So we learned that we define integer pointers with this star here, and it's going to be called age pointer. The body of the function should increment the value that age pointer points to. Okay, so what are we doing? So it's going to be age pointer plus equals 1. Weird Fox asks, is it possible to make undetectable malware using Python? Undetectable malware, if you're talking about making malware, I don't think it matters that much what programming language you're using to make it. Of course, I don't make malware, so I'm probably the wrong person to ask. You can probably make, well, I mean, undetectable malware, that's a hard ask. Because eventually all malware does become detected, especially after people get their hands on it. But, yeah, I'm not completely... You can certainly try making malware using Python if that's what you really want. Okay, so let's see, age pointer plus equals 1. So I think the body of the function should increment the value that age pointer points to. Okay, let's try this. Did you increment the value pointed to by age pointer by using... okay. So we need to specify that this is a pointer here. Okay. So inside the main function, define an integer age and set it to your age. Okay, so let's see. What are we doing? In the main function, integer age, it's going to be, I don't know, let's make it 99. Call increment age and pass the address of the variable age as the argument. Okay. Weird Fox says, I have made ransomware that locks all files, but my defender easily detects it. I'm a big noob in programming. Yeah, while managing to create a piece of malware that doesn't get detected by Windows Defender, that's going to be tough. It's possible, but you're going to have to do a lot of research on some techniques to make your executables not detectable by Windows Defender. I don't think I'm the person to teach you how to do that. You probably want to go and reference some sort of course. Okay, so what do we want to do? Call increment age and pass the address of the variable age as the argument. Okay, so it's going to be increment age, and we're going to pass the address of the variable age. Oh, gotta change the music. Okay, what music are we going to play now? How about we play some... Oh, Muramasa the Demon Blade. So this is a fun little action-adventure game. It's got some really cool music, and it's very, very Japanese. So I hope you enjoy this. Okay, let's go ahead and keep going. So let's see. We need to pass the address of the variable age. So the address of the variable age is going to be and age. Okay. Output the value of age after the function call. Output the value of age after the function call. Okay. So that would be printf. And it would be %d age. Weird Fox says, no matter how much I try, I don't understand anything my teachers teach. I'm worried if I won't be able to make a career out of it. There are lots of people better than me. It's tough. Don't compare yourself to other people. I think what you want to do, if you don't understand what the teachers are covering in their lectures, you could try talking to them. If talking to them doesn't help, you could try doing some real-life examples. The great thing about cybersecurity is that most of cybersecurity is centered around task-based learning. So basically doing little CTF exercises. So if you could find some CTF exercises that cover the material that you're doing in your course, it might help you understand better what you're learning about if you can get hands-on. Because if you work with something, for some people it's a lot more easy to understand than just reading about it or listening to somebody talk about it. Okay, so output the value of age after the function call. So we're just going to printf age over here, and let's see what happens. Okay, so it did increment to 100 from 99, so that's good. Alright, let's move on. Weird Fox says, I'm so poor I can't spend money on courses. That's why I'm looking for free resources. You know what? I understand. I understand the problem of looking for free resources, because there's a lot of stuff out there that's paid. And if you don't know what's good and what's not, it's hard to tell what is actually worth it as far as money is concerned. But what are you looking for? Yeah, there are lots of free resources out there. But what kind of materials are you looking for? So are you looking for stuff for are you looking for blue team cybersecurity stuff? Are you looking for red team cybersecurity stuff? Are you looking for digital forensics, or are you looking for network hacking or anything else? Let us know. We might be able to point you at some resources. Yeah, no, I mean very few things. Well, I'm not going to say very few things, but it's hard to tell what's worth it and what's not. That's why I try to use all free resources with the HackerFrogs program, because it's hard to ask people to pay for stuff when they don't know if they're not going to get their money's worth. Okay, so functioning prototypes. So far we've created function. We had to make sure that it was declared above the line in our code from where we are calling it. If not, the compiler will not have stored the function signature to check if the function call is the correct type in terms of return and parameter types. Instead of making sure our functions are always declared above, where they are called, a good practice is to define functioning prototypes at the top of our code. Let's see, WeirdFox says, I'm into pen testing. What can I get for free? So, as far as pen testing is concerned, there's a lot of good stuff for pen testing. Let me point you at a couple of things. So, TryHackMe is a great platform for learning about cybersecurity. There's a lot of pen testing and red team stuff there, red team oriented stuff there. Another good resource is Hack the Box. So the thing about Hack the Box is that it's not super beginner friendly, but once you've gotten to a certain point in cybersecurity, then Hack the Box is a great resource for cybersecurity stuff. Another great free resource for pen testing is what is it called? Portswigger Academy. So Portswigger Web Academy, it teaches all about. Aren't they both paid? So they both have free stuff on those platforms. There's a lot more free stuff on TryHackMe than there is over at Hack the Box. But if you're looking for stuff that's totally free, then you can look at Portswigger Web Academy, and the stuff there is totally free. Okay, let's go ahead and finish off the lesson, and then we can move on to the next part of today's stream. Okay, so we're talking about functioning prototypes. So when we create a functioning prototype, we don't actually create the body of the function. So we just provide a type, a function name, and parameters. So in this case, there's going to be upper function and lower function. We need to provide what is actually going in the parameters, and we need to provide the type of information that's returned. But that's all we need to provide. So in the above example that shows two function prototypes towards the top of the code, the main function calls upper function, which then calls lower function. Upper function knows about lower function due to the function prototypes at the top of the code. The compiler is made aware of each function signature before the entire body of the function is implemented. WeirdFox says, I once tried TryHackMe. After 2 days, they don't let you do anything without paying, and I'm stuck on the subscription page. Okay, so this is what you do in TryHackMe. So you got TryHackMe over here. I think what you're trying to do was you're trying to take a look at the paths. And what you need to do instead is you need to look at the search page. So here's the thing about TryHackMe. They're trying to make money, of course. And if you go over to their learning paths, they've got all these different learning paths. Some of the modules in the learning paths are going to be free, and some of them are going to be paid. What you should do is you shouldn't use the learning paths. Okay, maybe I shouldn't say you shouldn't use the learning paths. When you take a look at the learning paths, say we're taking a look at, I don't know, what's Web Fundamentals. Say we're looking at Web Fundamentals. They're going to show you all the modules they use. So you've got Section 1, Section 2, Section 3, Section 4. So the problem is that they don't tell you which of these modules are free and which of them are paid. Which means that you're never going to be able to finish any of these learning paths unless you're paying. That's fine. As long as you know which ones are free, then you can just do the ones that are free and then skip the ones that are paid. And another thing you can do for TryHackMe is you can go over to the Learn page. So click on Learn, and then click on Search. And when you click on Search, you can search for any keyword. But in the output, you want to make sure that the subscription type is set to free only. So you just set this to free only. And let's say we wanted to learn about, I don't know, let's say we wanted to learn about file upload attacks. Then there's all the rooms with file upload stuff that are free, because we set that up in the search over here. So whether or not TryHackMe is worth it as far as paying for it is concerned, I think it's pretty good. It's the subscriptions have gone up in price a little bit. It costs like $15 US each month, but it's pretty good value for your money. But I hope that all helps. Okay, so what are we doing? So one thing to note is that the names of the parameters associated with the function are not necessary for the function prototype. The compiler is concerned with three things when it comes to function prototypes. That is the function name, the return type, and the parameter types. So keep in mind that it only cares about types but not names. It does care about the function name, however. Function prototypes are good practice in C and can help you expand your code without any unforeseen errors due to the compiler not knowing about a function signature. Okay, so number one. Currently, the script C gets a warning as it seems there are functions being called before they are declared in the program. So just under the include statement, create a functioning prototype for repeat digit. And then just under the first prototype, create a function prototype for getRandomNumber. So what we're going to do is we're going to create a function prototype for repeat digit, and then we're going to create one for getRandomNumber. Okay, WeirdFox says, I didn't know this, and I know that the paid ones are more worth it, but as my current situation, this helps me a lot. Very thankful to you. Thank you. Oh, no problem, no problem. I'm here to help. If anybody else has any questions about where to go for different training resources, I don't know about all the different categories in cybersecurity, but if you want some resources, go ahead and ask, because I'm here to help everybody. Okay, so getRandomNumber. Let's make one for this. And we got ads on Twitch, so we got ads on YouTube as well. And let's go ahead and put on some birds. How about this bird? Okay, we'll be back in about a minute. I just have to have a little sip of water. We'll be back. Enjoy the birds and the music. Looks like we've got a picky eater. Oh, okay. So this bird only wants certain seeds, so it's so it's digging around in the bowl trying to find the seeds it wants. Anyways, let's put the birds away, and then we'll continue on with the lesson. WeirdFox asks, "Are you in the USA?" I'm not in the USA. I'm in Canada. It's pretty close to the USA. It's not exactly the USA. All right, put the birds away. And what do we need to do? So whenever we do these prototype functions, we need to figure out what is being returned. So we see later here that the repeat digit function returns void. So we need to include this up here, void repeat digit, and we need to include the type in the parameters as well. So this is an integer. Okay. And the second one is going to be getRandomNumber. So getRandomNumber is going to return an integer, and it's going to take in an integer in the parameter. So this is going to be getRandomNumber int, and in the parameter we also have to include int. Okay, so I think this is all we need to do. Let's run this. And okay, that's what we need to do. Awesome. Okay, let's finish up the lesson over here in the summary. So great job learning about functions. We've managed to cover many important topics like functions. So they're a named set of instructions. Functions can take in a set of inputs and produce some output. Functions help you write dry, don't repeat yourself code. C comes with many libraries that contain useful, ready-to-use functions. Function calls can take arguments and return values. Functions are made up of a function, signature, and body. Void can be used as a return or parameter type. A function returns a value with a return statement in the body. A function can have parameters that are placeholder variables for the function. Pointers can be used as function parameters to help with memory management. And function prototypes are good practice in C. So with the help of functions, you can now build larger, cleaner projects. So instructions. Try to refactor the code in main function from the beginning of the lesson with all the knowledge that you have. Okay, so let's take a look. What do we need to do here? You can also use the space to play around and explore your knowledge of functions, have fun. Okay, so it says try to refactor the code in main function from the beginning of the lesson with all the knowledge you have now. Okay, so what do we have here? So we got repeat digit, we got get random integer. Refactor the code in the main function from the beginning of the lesson. Wait, is this the code from the beginning of the lesson? Well, I guess it is. Huh. Okay, so if we just run the code, what happens? So it goes 4444. So let's try to understand what's going on here. So we get our placeholder function signatures over here. So repeat digit and get random number. And what is repeat digit? So we need to figure out what repeat digit is doing. So this is a function that returns nothing, so it returns void. And it's got a parameter called repetitions. So repetitions is an integer. So it's going to define a digit, an integer digit, which is get random number 9. Get random number 9. So the problem is that get random number is defined after this. So this isn't the way you want to do it. What you really want to do is we can actually get rid of this. And what we can do is we can just copy paste the code from the later function we can include it before. So we're just gonna, how do we, I think we can cut this. So cut this, we're gonna put it earlier in the code. So yeah, the reason we do this is because this function already needs to be defined before we actually run it later in the code with repeat digit over here. Okay, so, sorry, what are we doing here? So get random number 9, so get random number, it's basically going to get a random number with the max value of whatever is passed in as a parameter. So for I in, okay, then we do a loop. So this is going to be a for loop, and it's going to be I is greater than repetitions. Okay, so it's just going to run over and over again until the value passed in repetitions is reached. And it's just going to print the digit. So we can see here that these digits are printed out. And then it's going to print out a new line. Okay, so inside the main function, we got srand time null, and this is the line that's going to make sure that the numbers are random each time we run the program. So we got repetitions, it's going to be get random number 10. So it's going to be up to 10 numbers, and then we run the repeat digit on the number of repetitions. Okay, so if we run the code, yeah, so this all works. Alright, so we finished the course. Good. We're going to skip this because we're going to be moving on to our next subject for this today's stream. Okay, so let's see. Why are we talking about scope? So, Codecademy is another one of these platforms where most of the stuff is paid. They do have some free stuff, and when you use the free stuff, they're always asking you to pay for more stuff. Because that's what they're trying to do. They're trying to make some money. Anyways, let's go ahead and move on to the next part of today's stream. So in this last part of today's stream, we're going to do some Windows hacking. So we're going to be continuing on from where we left off last week on Friday, and we're going to be doing the Peel It challenge over here from thehackerslabs.com. So this is the link for the challenge if you're interested. And what we did is that we discovered that in this challenge that there was a vulnerable, what is it called? A vulnerable network service that was susceptible to buffer overflow, stack buffer overflow in particular. So what we're going to do today is we're going to figure out if we can attack the stack buffer overflow in this CTF lab, and then we're going to try to compromise the box. So to do that, we're going to be using TryHackMe, and we're going to be testing out the buffer overflow on this machine on TryHackMe. It's called Buffer Overflow Prep. So Buffer Overflow Prep, we're going to start up this machine. Let's see, where's the machine? Here it is. Okay, start the machine. Okay, so we're going to access this via... I think we're going to access this by... I think we're going to use the attack box to access the machine. But can we... do we have access to the box directly? I don't remember what we did last time. That's okay. So the other thing we need to do is we need to start up the vulnerable Windows machine. And the vulnerable Windows machine is the one that we downloaded from the hackerslabs.com. And we've got it just over here. So once that boots up, we'll be able to access it again. So if you have any questions about what we're doing and exactly what's going on when we hack this box, please let us know in the chat. We'll try to explain as best we can what's going on. So it looks like this is running now. And let's go ahead and set up some tabs. So this is going to be for Nmap enumeration. And we need to figure out where this machine is on the box again. So it's been about a week, and we need to figure out where this machine is in our network. What we're going to do is we're going to quickly find out what the network range is. So the network range is going to be this range right here. So this is the ETH1 interface. This is the IP address. So we're going to use an Nmap scan to figure out where the machine is on the network. So it looks like it's on the number 3 address over here. And we're going to scan the machine using Nmap. So Nmap is a very useful program for finding out which machines are offering which network services and ports on a particular machine inside a network. And in this case, we're going to scan this particular machine to figure out which network services are open on the box. So it tells us that there are these different ports open on these different networking services and ports open. So there's port 80, there's port 445, there's port 139, 135. So we've actually done most of this last week. And what we discovered was that there was a web page on port 80. So let's go ahead and go there, because that's where we discovered the vulnerable service. Okay, so we're going to go to HTTP 192.168.50. Was it 56? Let me check one more time. This is 56. 56.3. Okay. So this is so the hackerslabs.com. This is a Spanish language cybersecurity platform. So all the machines that we download from there are going to be Spanish installations of Windows or whatever operating system. So everything's going to be in Spanish. This is an error page. But the interesting thing about this is that if we take a look in the HTTP source code, there's actually something hidden at the bottom over here. So the thing that's hidden at the bottom is going to be this particular endpoint. So we know this is going to be a directory because it starts with the slash. So this is what we're going to check out. So if we check this out over here, this is going to have some files that we can investigate. So we find some files in this directory. So we've got essentialfunctions.dll. This is a library function. DLL stands for, what does it stand for again? The something dynamic link library. So this is a type of library file that is used with Windows executables. And vulnserver.exe is another Windows executable. So we're going to investigate these. So we're just going to, well, we can just left click and download these files. Hopefully they get downloaded. Let's take a look in the downloads directory. Okay, so what do we have? We downloaded the essential functions file, and we downloaded the vulnserver.exe file over here. Okay, so now that we've got these two downloaded, we can actually investigate this online over here. So we got these ports open, and we actually don't get the report yet that there's an unusual port open yet, but that's eventually going to happen. What we're going to do is we're going to set up a test computer. Because this is running in Windows, and we're not running in Windows right now, we're running in Linux, we're going to have to set up a test computer to test out this vulnerable service. So what we're going to do is we're just going to go over to try hack me, and we're going to try to access this this machine over here. I can't remember which program we used to do RDP. Let's see, which program last week did we use? GX000 says a whole test computer. A whole test computer, yeah. We're using TryHackMe's test computer, is what we're doing. So this is going to be very similar to the old version of the OSCP exam, where we had to do buffer overflow on one of for one of your machines. But what was the program that we used? Sick in the Mind. Hey, Sick in the Mind. Hello, welcome to the stream. I thank you for all the help you provided on, well, what day was it? Was it Monday? It was no, was it Friday? It must have been, no, it was Wednesday, right? Yeah. No. It was actually pretty recent. But thank you very much for all the help. Did you end up figuring the rest out? You know what? Yeah, no, my brain was also I'm out after a while too, because I was staring at that problem for about 2 hours or so. 2.5, 3 hours. I don't know. I'm going to investigate the problem that we were doing in greater detail. We were taking a look at padding oracles, I think they were called padding oracles in web apps, and yeah, I was not having a good time. I was not having a good time at all. But hey, Second in Mind, do you remember? From what I could read on it, that script was what I could figure out. Okay, okay. Do you remember which program we used to access the network last time on Try Hack Me? It was not FreeRDP. Was it Remina? It wasn't Remina. It was, yeah. First we needed to use OpenVPN, but Xfree. Oh, okay. Well, I mean, I think we tried using this. We're having a hard time installing this. So I think we ended up using another program. I need to take a look at my history to figure it out. Let me see if I can spot the command. I think we ended up using another program. It wasn't Remina. It wasn't was it our desktop? It might have been. Yeah, that might have been it. Okay. But anyways, let's before we do this, we need to log into the Try Hack Me network. So let's go ahead and do that. I think I put it... Did I put it in the downloads directory? So let's see. It should be this one. Okay, so what was it? OpenVPN. Yeah, this is it. Our desktop. Okay, let's go ahead and access the machine. We've got 2 hours. That's good. I guess I can call this one our desktop. And you know what? We should color code our tabs just, you know, to be fancy. And this one will be, what is this? OpenVPN. Yeah, but how's your week going, Sick in the Mind? It's over. It's over now. Thank God. Okay, so our desktop. Whoops, this isn't the right IP address. Gotta get the correct one. Finally, yeah, right. It feels like it's been a really long time. Paste in. Nope. What was that? Why can't I get the IP address? Copy the IP address. Maybe I should just remember the... Close the week with the pen test report and have a good weekend. How many days do you get for pen tests? I remember when I was working, I only got 3 days. I got 3 days to do a short pen test report. Hopefully you get more. Hopefully you get something like 5, or it depends on the size of the app. So do you also get 3-day pen tests where you get basically 1 or 2 days to... We get 2 days to scan the app, and then... I did my report in a day today. So 10-10, 236, 175. 10-10, 10-10, 236, 175. Okay. So let's see. Sick of the Mind says, I had 2 weeks for this application. So 2 weeks for an application is a pretty generous amount of time. Depends on how much functionality there is in the application. You're talking about a web app, right? Okay, so our desktop, is it running? I also take a bunch of other responsibilities as a lead. Yeah, no, I understand. Were the only person testing the app, or did you have a few other people taking a look at the app as well? Because I remember sometimes you had multiple people taking a look at the same app. You were the only person testing it. Okay. Why isn't... Am I not connected? I need to check again. Oh, maybe I'm not connected. Huh. Okay. So if we're connected, we should have a ton 0 interface. So it doesn't look like we're connected to the network. Why that is, I'm not sure. Okay, well, let's see if we have a connection here. No, we still don't have a ton 0 interface. Maybe I need to re-download my key. It'll tell you when a tunnel is mapped. Yeah. It could be that this is an old key, in which case I need to download a new key. Let me get rid of my keys. So let me just remove all the keys. It's OVPN, right? Okay. Yeah, so we just got rid of all our keys. Let's download a new set of keys. So let's see. If I go longer than a couple of weeks with try hack me or hack the box, will refresh keys. So Sick in the Mind, do you like to do all the new boxes that come out every season on Hack the Box, or do you do other stuff on Hack the Box? Okay, so let's go ahead and download the configuration file. Okay. So we should have our OVPN key again. Let's run that. Okay, awesome. So we've got ton 0 opened, so I think we should be good to go. Let's see, I've been involved with OffSec's training, so I haven't had much time to do Hack the Box or THM. Eventually I'd like to get back to doing Pentester Lab to complete some of those new exercises there. Pentester Lab, yeah. Pentester Lab, I usually look for platforms where there's a lot of free stuff. Unfortunately, there's not too much free stuff over in Pentester Lab. There is a couple of good ones though. Pentester Lab is dope. What modules did you think were super good over at Pentester Lab? Just so that I can know to look for that stuff when I get there. Okay, so we've got our desktop here. I guess we'll log in as another user. And they gave us a set of credentials. So the credentials they gave us were... Let's go back. Okay, so it's admin password. So let's go ahead and do that. Wait, why did it close? Logout initiated by user. I didn't log out. Oh well, let's log back in again. Okay, so the other user, we are admin. Admin password. Okay, so this isn't going to be super big, but you know what? That's okay. That's okay. And this is Windows 7. I actually tried installing a Windows 7 VM recently because I was thinking maybe I could create my own Windows test machine, but Windows 7 is not very fun to navigate these days. Anyways, let's go ahead and copy some files over here. So the last time we were here, we copied files over. I think we used certutil to copy files over by using the desktop. Sorry, the clipboard. So let's go ahead and reuse that fun little trick. Why does no one mention Windows 8? That's a good question. That's a good question. Actually, Windows 8 was the better version of Windows 7. Sick in the Mind says the Packet Capture series was good. The code review exercises. Packet Capture series. You know what? I need to get better at doing Wireshark stuff. Yeah, MBS, it's my favorite. Windows 8. I used Windows 8 for a really long time before upgrading to Windows 10. Okay, so we're going to rename this session. We'll call it Our Desktop. No, this isn't Our Desktop, is it? Yeah, this is Our Desktop. Why did I call this one Our Desktop? Anyways. Research. Okay, so let's see. Jan BS says, kind of reminded me of Xbox UI. A little bit, yeah, a little bit. Let's see. Sick in the Mind says, I despised Windows 8, to be honest. I skipped directly from 7 to 10. That's... huh. Windows 8 was fire. Yeah, a dumpster fire. I don't know. What was it about Windows 8 that offended you so much, Sick in the Mind? Let us know. Okay, so what are we doing now? We need to copy over the files. So there's vulnserver.exe. So we're just going to cat it out, and we're going to base64 encode it. And we're going to copy this over to the Windows machine. So it's not... So here's a tip. If you need to copy a bunch of stuff to your clipboard, you can make everything super small, and that's going to make it a lot easier to copy stuff over. Because otherwise, it's going to be tough scrolling through all this stuff. So let me grab all this. Okay, and then copy that. We got ads on Twitch. So when ads are on Twitch, we put them on YouTube as well, and then we put on our birds. How about which birds? This one. This is a fun bird. Okay, we'll be back in about a minute or so. We're just going to wait until all the ads finish on YouTube and Twitch. Just gonna have a little water break. Be back in a second. This is the spotted towhee. The spotted towhee is a very, very shy bird that you can find in the Pacific Northwest. It's got these great red eyes, so that's one of the fun distinguishing features of this this particular bird. So you can see right over here the fun red eyes. It makes the bird seem a little bit sinister, but you know what? These animals can't decide what color eyes they have. It's a fun bird. It's got some fun markings. It's beautiful. Anyways, let's put the birds away. Let's get on with the hacking. Okay, so we just copied over the base64 content of the binary file that we want to move over. So I think what we used was certutil. So I think it was certutil base64 decode. So let me look up how to do that real fast. Cert util base64 decode. Need to figure out how to do that again. Okay, I guess first we need to create an in file and an out file. So certutil decode base64 encode out file. Sure, let's go ahead and do that. So back at our desktop, let's go ahead and make a file with those contents. So we're gonna create a notepad file, text document. So we're just going to call this vuln.b64. And in this document, we're going to paste in all the stuff. And then we're going to save the file. Okay, so this is the desktop directory, I'm pretty sure. So let's move into desktop. Okay, so vuln.b64.txt. So we're going to do cert util, and what was the syntax again? Dash decode. Dash decode vuln.b64.txt and then redirect it. Actually, we don't need to redirect it. We're going to b64 encoded and then out file. So the out file is going to be vulnserver.exe. Okay, so now we've got an exe file that we moved over, and we need to do the same thing with the DLL file. So let's go ahead and get that. So the DLL file is essentialfunctions.dll. Let's go ahead and make our terminal really, really small so that we can grab this easily. Still not that easy. Okay, copy all that. Copy. Then we're going to go over to our desktop again. We're going to make another file. It's going to be called essfunc.b64. Okay. And then we're going to use cert util again on essfunc.b64.txt, and we're going to redirect that into essfunc.dll. I think that's how you spell it. Huh. Didn't work? Wait, I must have spelled something incorrectly. ESS... Oh, I forgot to paste in here. Man, silly me, silly me. Okay, paste in the stuff. Okay, save that out. And let's try the decode again. Okay, so we got the DLL file here, we've got the vuln server here. All we need to do is set up our immunity debugger. So we got immunity debugger. Let's go ahead and start it up. This is still really, really hard to read. Okay, so what are we going to do? We're going to, we need to run the vuln server. Oh, I can't. This is so hard to... Okay, let's close this for now. Okay, we're going to start the vuln server. And is vuln server running? Okay, here we go. So let's see. I think I can make this all bigger. This is what I should have done first. Okay, let's make everything nice and big. Yeah, okay. This is exactly what we want. I don't think we're going to be using this this command prompt anymore. Let's get rid of it. Okay, so we've got the vulnerable software that is running. It should be on port 9999. let's go ahead and check that with Nmap. So the reason why we're paying attention to this is that this software is running on the machine that we want to compromise on port 9999. And I think it should be running on the other machine on that port as well. Let's go ahead and check it out. So the address that we want to check out is 1010. What is the IP address? 236.175. 236.175. I would check it with Netcat. Yeah. I think we should check it with Netcat, but I just want to confirm that. Actually, I want to see what Nmap thinks this service is. It's definitely going to be wrong, but I just want to see what. You don't want to send intense Nmap scripts because if it's intentionally vulnerable, it'll take it down. I'm pretty sure it survived the Nmap scan last time. But okay, let's try accessing it on with Netcat instead. So that would be Netcat. This IP address 9999. Okay. So I think the vulnerable function, I think, was the kstat function over here. And if we just send it a crap ton of input over here, it's going to crash the server. So I just want to make sure that we're sending enough. Okay, that wasn't enough. Let's go ahead and copy even more so that we can crash the server. So it's kstat, and then paste in like a bunch of input over here. See if it crashes. That wasn't enough to crash it. Huh. Hold on. The thing is that we need to know it's still up. It looks like it's still up, yeah. We need to know exactly how much input we need to send to crash the server. Check it out on the Windows box. Yeah. So the Windows... It looked like it crashed. It looks like it crashed. Okay. So close the program, sure. Restart the program. Waiting for client connections. So sometimes you won't get a response at all. With Netcat, it's hard to tell. Yeah, that's true. Netcat's not super good at sending you. That is a lot of. At least you get a lot of A bytes returned. Yeah. So this is what we forgot to do. We forgot to set it up and link it to Immunity Debugger. So now that it's running, we might as well connect it to Immunity Debugger now. So where is it again? Here it is. It won't be able to tell the difference between your line break or a line break. Okay, so we got Immunity Debugger here. I think we can make everything a bit bigger. Or maybe not. Wow. This is not super responsive. Okay, let's go ahead and attach. And the process is called vuln server, right? Where is it? Vuln server, here it is. Okay, so we're having a big problem with the visibility of the stuff inside of Immunity Debugger. What I really want to do is I want to set the appearance for the font. And I think we're trying to use a Unicode font. So this is a little bit better. This is a bit less crappy on your eyes. But it's still hard to see. But we won't be spending a lot of time looking at this. so that's okay. Okay, so the attach process, it's paused, so we're just going to start it up. So let's see. How do we run it? We run it with this button over here, I think. Okay, so the program is running now. And let me take a look at my notes. In my notes, I noted how many bytes we need to send. Let me open up my write-up. Man, everything's so slow right now. Let's see. This was the Hacker Labs. And this one was called Pila. Okay. So this is what I wrote last time. VM needs more memory. It sure does. Okay, so the buffer overflow is in the kstat command, and the following payload causes a crash. So kstat, all of this stuff over here, and it looks like the offset we found was 77 bytes, but we need to send a lot more to the application to actually crash it. So let me figure out how many characters this is, because we're gonna have to write up a little Python script to figure out the to automate this what is it called? This the hack writing. The hack writing. Anyways, let's echo this stuff out, and we're going to word count it. Man, my terminal is really unresponsive. So this is 800. We probably know... Neems, hello! Nice to see you here. What is good? We're just continuing a box that we did last week. So we're just trying to figure out how to do a buffer overflow attack. We need to do it in a few different stages. So this is 800 characters. So we should probably confirm. Cypher Enigma, hello! Nice to see you here. And welcome to the stream. Geez, I haven't done enough of these redeems here. How about we do one for War Games? Here you go.
We're in.
Shall we play a game?
How about global thermonuclear war?
Okay, so what do we have? Sick in the Mind. Sick in the Mind, did you watch this movie? You must have watched War Games. It's, I think you have got kstat in there twice. Do I? Oh, I do. I should probably get rid of that. You've seen both. Both War Games and what was the other one? Let's see. We do have kstat in there twice. We should get rid of that. No. Actually, let's call this the payload. So let me just go in here and get rid of that extra kstat. They made a sequel? Was it any good? Okay, the fact that they made a sequel is not super surprising, but was it good? I guess because people don't talk about it, it probably wasn't very good. There you go. There's the extra kstat. It was B-movie AF. So good. So good? Really? Okay. Okay, so this is the payload that should crash the application. Let's go ahead and send this payload by netcat. No. Okay, so it's running in here. Sure. So netcat, let's paste in our payload. This should have crashed the application. It's like pitting ChatGPT versus DeepSeek. Was that what it was like? Okay, let's go over to the application. Did it crash? Okay, so access violation while executing 3333341. Okay, so I don't think this offset is quite right. Let me try adjusting. Okay, so we're going to file. Can we... What is the... How do we reset again? Debug, restart. Okay. So we'll restart the program. And then we'll run it again. And I think we need to move the payload up a little bit. So let me take a look at that payload again. So I think, yeah, this should be, hold on, can't. So we should be able to figure out the offset from crashing the program one more time. And we go back here, and yeah, so we managed to fill up the IP register with what we want. So if we take a look at the IP register over here, EIP, it's filled with these hex 33. So hex 33 is the 3-character. And what are we doing? So over here, this is the offset. This is the exact offset where we can put in our code. So let's figure out exactly what that offset is. So this is offset 80. So 80 is the entire string. That means that the offset is actually 4 less. So it's actually 76. So the offset is 76. So I think what we need to do is we need to create a little Python script. And I'm pretty sure... I think they include a Python script to use in this room. Let's see, I've gotten a handy guide for buffer overflows with the help of Mona over here. So there's good old Tiberius. Mona configuration and fuzzing. Yeah, so they've got the basic Python script that they use for testing this thing over here. So let's go ahead and use the Python script then. Nano buffer.py. Actually, maybe we'll call it overflow.py. It's important to name yourself properly, of course. Okay, so what do we got? So we got our prefix overflow1 and then space. So I guess the prefix is going to be a KSTED in this case, right? We got our IP address. We've got the modules that we're importing, like socket and time and sys. We need to replace our IP address. Actually, they've put in the IP address for us. That's nice. The port is going to be different. It's going to be 9999. The timeout we can keep the same. The prefix, we're going to make this kstat. And then the string is going to be the prefix plus a times. This is Python 3, right? Just checking, because sometimes Python 2 stuff sneaks in and then you're having a bad time. Okay, so a times 100. So it's not going to be a times 100. It's going to be kstat. We need to subtract. So okay, we figured out that the offset is 76. We need to subtract the prefix from the offset. So this is 246. So 76 minus 6 is 70. So we send 70 A's. So while true, we're going to do our connection with the socket over here. So socket, we're creating the socket object as S. So socket set timeout, socket connect, socket receive, and then print fuzzing with whatever bytes. Wait. Oh no, we're not fuzzing. Well, I mean, maybe we should... I think we know... Well, okay. We don't know exactly how many bytes it takes to crash this thing. We know we have sufficient number of bytes in our payload. And... the payload is like 800 characters. So do we need to send exactly... Hold on. So I think we're looking at the wrong Python script here. It's nice of them to include the Python script to help us out here. But this is the fuzzing part. Right. So we're past the fuzzing part. We need to replicate the crash and then control the EIP. So this is probably what we want to use as our script instead. Okay. Let's go ahead and go in there. Oh, we didn't even save this. Okay, anyways. Get rid of all this. Paste in the new stuff. So this is a much shorter script. So here we've got space for a bunch of different variables. Stuff like the return address, the return. So this is basically the EIP, what we're going to be filling the EIP with. We've got our padding, we've got our payload, we've got our postfix, and let's go ahead and set the port and set our prefix. So our prefix is going to be kstat. Offset is going to be 70. So the overflow is going to be A times offset, which is 70. The return, let's just do 3333, just so we can confirm that that this is exactly the number we want. So the buffer that we're going to send is going to be the prefix plus the overflow plus the return, the padding, the payload, and the postfix. We're going to connect via S as a socket object. We're going to do our try accept. So try connect on the IPN port, sending the evil buffer, and we send the bytes. Print done, except could not connect. So let's see if we can get this to work. It should work, because it is on the TryHackMe website. Anyways, let's take a look at the... Okay, so I think we restarted this already. Let's just restart it one more time for fun. Then we run it, and then we run our script. We'll call this hack testing. Let's give this a fun color. Let's make it orange. Okay, so Python overflow.py. Okay, so let's see if that crashed the program. I don't think it crashed the program because we didn't actually send all that much. So if we look back at the... That actually crashed the program. But in this case, yeah, the EIP is filled with the three. So I guess we don't need to send all that many. Sick in the Mind says that looks like the it looks like a proof of concept if I've ever seen one. Yeah, the A's are in the ESP, right? So that means that we can probably put some shellcode in there, right? So the next step is we need to figure out what... I don't remember how to do the bad characters part But anyways, let's go back. Okay, so let's take a look at the script again. So we actually didn't send very many bytes. Let's see. Sick of the Mind says, first you want to step back. Step back. And send incrementing chunks until it crashes. Incrementing chunks until it crashes. So we know that it has to be... I don't know if we need to do that much experimentation. Because we know that we need to send at least 70 bytes and then send whatever to the EIP. Okay, so Sick of the Mind says we send incrementing chunks until it crashes. This is to narrow down the offset. So narrow down the offset. I don't think we can... Yeah, 70 A's will put... 70 A's plus 3333 is going to enter the EIP. So I don't think we need to figure... We don't need to fiddle around with that too much anymore. The next thing we need to do is we need to figure out if there are any bad characters. Because if we're going to be creating some shellcode by using the forbidden platform, we need to we need to figure out if there are any bad characters. Yeah, bad bytes. So I need to educate myself on how to do this again, because I don't remember how to do it. I think there should be a little guide in the buffer overflow prep room. So let's take a look. Oh, that's way too big. Mona can print the bad bytes array. Yeah, I need to teach myself how to do that again. So let's see, finding bad characters. Okay, we got more ads on Twitch, ads on YouTube then, and then let's put on some birds. How about some sparrows? Okay, so we'll be doing our break for about a minute. Please enjoy, and I'll be back in a minute. I just have to have a little bit of water. Okay, we got another... Oh, man. You know, there's something so satisfying about watching birds eat. I don't know why. But yeah, just, you know, watching the Stellar Jays come on over and gobble up a bunch of peanuts. I don't know why it's so satisfying. Sick of the Mind says, Mona Byte Array CBP X00. CBP, I'm sure that's what you've got in your notes. Okay. But, you know, Sick of the Mind, did you take the OSCP when they still had the buffer overflow part in the exam? I think you must have. You must have. Yeah, of course you did. Because you've been at this game for a while. Okay, let's put the birds away and let's continue on. So let me do a little refresher because I need to educate myself on this too. The last time I did this stuff was over 2 years ago, over 3 years ago at this point. So I need to educate myself again. So finding bad characters. Let's see. The staff recognized me from my presence in the IRC. The IRC, wow. IRC is pretty old school. So let's see. Generate a byte array using Mona and execute the null byte by default. Note the location of the byte array.bin file that is generated. If the working folder was set up per the Mona configuration section of this guide, the location should be cmonaocp byte array.bin. Huh. Okay, I should probably do that first. Okay, let's... Where do we do that? Mona configuration. When Immunity loads, click on the open file icon, file open, then the OSCP folder, select the OSCP binary, KK. The Mona script has been pre-installed, however, to make it easier to work with, you should configure a working folder using the following command, which you can run in the command input box in the bottom of the Immunity debugger window. Mona config set working folder c Mona something something. Okay. Let's do that. Let's go ahead and reset this thing. Okay, so let's run set working folder c Mona something. Did that run? Okay, it must have. Let's see, that loop is clean though. Honestly, just use that for loop. Okay, so c Mona something something. Let's go ahead and open that. C Mona. I don't see Mona in here. Hold on. C Mona. Oh, gotta create it. Okay, so C Mona what? C Mona P. Okay, sure. Alright. Let's run that command again then. I guess they would have created it when they started writing files as well. But anyways. Where were we? So finding bad characters. Let's see. Note the location of the bytearray.bin file that is generated. And so we run this command. So Mona bytearray b something something. So this for loop, it looks pretty good. Let's run the command in Mona. Okay, so this is the... I mean, I guess I could copy from here. C Mona vuln server bytearray.txt. I might as well go and get the one over in here. Let's see. Mona vuln server bytearray. So am I using the text file or the bin file? Now generate a string of bad characters that is identical to the byte array. The following Python script can be used to generate a string of bad characters from hex 01 to hex FF. Update your script and set the payload variable to the string of bad characters. Set the payload to the string of bad characters. Okay, so let's go ahead and do this. I'm going to call this bad.py. Actually, badcar.py. Okay, paste in the stuff. Save modified buffer, run the script. Okay. So what does it want us to do? It wants us to update their script and set the payload variable to the string of bad characters. Okay, so let's go back into here. Let's see. Hoi Minoi. Hoi Minoi. That's a fun name to say. I love your streams. They're so informative. I can never read anything. The cute birds lose too much. The cute birds lose too much screen real estate. Never read anything. So, you should be able to read this. The problem is that I can't do very much about the resolution of the stuff in here. But that's okay. That's okay. If there's something that I want to point your attention to, I'll try to make it bigger. But I'm afraid I can't really make this text over here big. I can make this text bigger. Okay, so we've got our payload. So we're going to set our payload to be... Where's the payload? Padding plus payload plus postfix. Okay. Paste in the payload. All the bytes. Let's see. You could always whip out the magnifier on the RDP host. I appreciate it, no worries. Oh, yeah. So, can we whip out the magnifier? Magnifier. Oh, wow. Well, I mean, the thing is that these, yeah, this is really hard to see. The problem with the magnifier is that this machine doesn't have very much... Well, I think it doesn't have enough memory. It doesn't have either enough memory or enough CPU power. But using the magnifier makes everything impossible to read. How do we shut off the magnifier? It's on the taskbar. Okay, let's go ahead and shut down the magnifier. Holy. Can we close this window? Please? Okay, jeez. That was tough. That was tough. Okay, anyways, we're back. Let's, so we got our payload over here, and we're going to try to see if we can find the payload in the memory after it crashes, right? Okay, let's save this out, and then we're gonna run the script. So python overflow.py. We should see that the program crashed. So it says, oh, did it not crash? Hold on, let me restart the program. So when I first discovered cybersecurity, I thought buffer overflows were the best. I thought they were so awesome because it was all about experimenting and looking around for different clues. And I thought this is real hacking. But of course, you know, there's a lot of stuff that's hacking. But there actually, you know, the buffer overflows are very cool. Anyways, let's go ahead and run the script one more time. And yeah, so this worked. What are we supposed to do? Where do we look? So let's see. Restart. Okay, run the modified script. Make a note of the address to which ESP register points to, and use it in the following Mona command. Let's see. So Mona compare bytearray.bin a address. So let's see. The ESP register is pointing to what? Maximize your CPU window. It's at the bottom. You need to resize those panels. Yeah, let's do that. Oh. Man, this machine is so unresponsive. I didn't know that Mona could just compare that address location with the byte array bin. Oh, well, I mean, apparently. Yeah, this thing locked up. This machine locked up, jeez. I can't click on anything. I feel so bad. You feel so bad about what? No. I mean, that's fine. You know, is it the magnifier that that crashed the dang thing? Anyways, let's get rid of this connection. We'll try connecting again. That's some good advice. Okay, so our desktop. Let's run it again. Sometimes our desktop takes a big steaming one. So admin password, sure. Hoimino, you don't have to worry. You don't have to worry. Even if something actually happened, it's not your fault. Okay, I think we can start doing stuff on here again. That's good. Let me see if I can resize this window a little bit. Okay, that helps a little bit. Okay, what was the command we were supposed to do? We were supposed to do this, Mona compare. And we're supposed to get the address of the ESP. The ESP is currently... Oh, this is hard to see. Okay, let's see if we can make this font a little easier. Font all? Yeah, we can do font all. Courier. This is easier to read. This is easier to read. Okay, so the ESP is this. I can just can I copy this? Yeah, I can. Awesome. What was that? Sick of the Mind says, kind of weird that they used the phrase OSCP in their steps. OffSec's going to go after them. I think, well, this challenge, unable to find OSCP byte array.bin. Oh, yeah, we need to change this because it's not called OSCP. It's called vuln server. Okay, let's try that again. Okay, so it found something. Unfortunately, we've got bad characters 0, 0, and 15. So we need to update this. 0, 0, and 15. 0, 0, and 15. So a pop-up window should appear, comparison results. The window shows the results of the comparison, indicating any characters that are different in memory from those that are generated in the byte array.bin file. Yeah, it is a pretty nice iterative method. Not all of these might be bad characters. Sometimes bad characters cause the next byte to get corrupted as well, or even affect the rest of the string. So the first bad character in the list should be the null byte. And since we already removed it from the file, make note of any others. Generate a new byte file in Mona specifying these new bad characters along with x00. Okay. So you don't have the... Oh, okay, so Hoimanoi says, do you have any certs or just a lot of hands-on knowledge? I do have one cert. It's not a super prestigious cert. It's the EJPT. Aside from that, I did go through OSCP training, but I didn't get my OSCP certificate. Let's see. Sick of the Mind says you don't have x00 in your bad byte array. So yeah, it shouldn't be in the array. If we take a look at the Python file, where is it? Here. So this one doesn't have hex 00. It starts at hex 01. So let's go ahead and we need to get rid of hex 15. So this was one of the bad bytes. So let's go ahead and get rid of that in our payload. So hex 15, or hex 15 rather. So get rid of hex 15. Save that out. Thank you very much. Thank you very much for following. Banker Doozy, thank you. You are now HackerFrog. Let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up again!
Sick of the Mind says it's easier now. Yeah, OSCP should be easier now because they've got, what was it? They have, most of it is Active Directory. And Active Directory stuff, it's probably easier to deal with than random stuff that's not even in the training. But yeah. Sick of the Mind says, I always fill in those with XFF so they don't lose their spacing in the table format. You know, that's probably not a bad idea either. So maybe I should do that. Whoops. Oh jeez. I accidentally ran the Python script. Okay, so where was that? That was between 14 and 16. So let's replace that with hex FF. Yeah, hex 15. Let's see. Sick of the Mind says, I'm only doing A+ because WGU requires it. Sick of the Mind's Hoi Minoi says, I'm currently doing A+, CCNA, and Sec+ route, but striving for SCP and others. And thank you very much for X-Ha-He. X-Ha-He? Finishing my bachelor's. Huh. You're doing a bachelor's in computer science or in cybersecurity? I never got it, but I'm taking a term break. Okay, let's go ahead and keep on keeping on. So we removed the hex 15, hex 15, and we need to create a new byte array in Mona to reflect everything, right? So the byte array we did with this. So let's go back to the machine. Okay. And we create our new one. So the byte array is going to be in okay, done. Let's see, Sick of the Mind says, it's just cyber, but I honestly feel like I should switch major to computer science. Computer science, well, I mean, cybersecurity degree, it might be a little bit limited compared, considering like where you are in your career. Yeah, I think computer science might be more useful, and I think the curriculum, like the courses you have access to, are probably more relevant to what you want to learn. How do you pronounce your name? X-Ha-He? I'm not sure. Let me know how to, using you as more support, staying home to do some studying. Are you studying X-Hey? X-Hey. Okay, that's great. What are you studying? Are you studying cybersecurity or computer science or something else? Okay, we created our new byte array, great. And let's go ahead and keep iterating. So a pop-up window should appear called Mona Memory Comparison Results. Okay, great. First bad character. Okay. Restart the binary and then run the modified script again. And then repeat the bad character comparison. Okay, let's do that. So let's restart the thing. And then let's run the thing. And then let's run the script. So we're going to do overflow. Whoops, where are we? Here. Okay, so the thing crashed, right? Yeah, the thing crashed. Then we need to do the comparison. And what was the command for the comparison again? Monocompare. Cybersecurity. Okay, XHey says, cybersecurity, I want to get CDSA from Hack the Box. Looks like a fairly easy win. Going to relax on the offensive side for a bit. Oh, how much have you been studying cybersecurity? Thank you very much for the follow, Hoi Manoi. Thank you. And welcome to the HackerFrogs. CDSA from, let's see, CDSA, that's the defensive one, right? That's the, I'm pretty sure that's the defensive one. So we're looking at the ESP. I guess we can keep on copying this thing, right? Copy, paste. Oh, one more time. We need to keep on changing the name of the directory. Okay, so we got bad characters hex 00, hex 15, and hex 16. So we need to add, yeah, defensive analyst, yeah. Okay. Yes, it is. I've been obsessed and enjoying cybersecurity since graduation in 2019. Did you graduate with the cybersecurity bachelor's degree? Let me know. Let me know. Thank you, XHey. Okay, so let's add hex 16 to the bad characters list. So hex 16. So 16 is here. We're going to remove it. And let's go ahead and create our new byte array. So the new byte array is going to be this command. I think we can do command history in the in this console here. Yeah, we can. Actually, no, we can't. Never mind. I thought we could. No, we can do. Okay, great. Okay, so it's hex 00, hex 15, and hex 16. I've always inspected the fields directly in memory. This method is kind of foreign to me. Yeah, this is more, well, I mean, this is more of an automated method. I think, I understand the method that you're talking about. It's basically taking a look at the memory addresses directly and like scanning for bytes that are there and bytes that are not there. But that's actually, it would be very, very tough. It'd be tough to do that because the text is so small. Back on N3. Hello, nice to see you here on YouTube. Welcome to the stream, and here's a desert frog.
Hide the planet! Hide the planet! Shut up again!
Okay, so we just added the hex 16 to the bad byte array. Let's go ahead and keep on moving. So let's reset the thing. Oh man. So basically doing this kind of checking for buffer overflows is it's a very iterative process, and eventually we'll get there. We just do have to do a lot of repetitive work first. Okay, so this is set up. We removed 3 bad bytes, and let's go ahead and crash the program again and figure out if there are any more bad bytes. So That should crash the program. Yeah, it crashed the program, and let's go ahead and do the comparison. So the command was this one. And is this the same address? FF. No, it's not the same address. Okay. So let's replace the address. We've got one more. It was the same except for one F instead of FF. Okay, so we got 17. So we got this list of a bunch of bad characters. Okay, I think we'll add byte 17 to the list. Okay, and then we're going to remove 17 from the script. So the script is here, remove 17. Okay, save it out, and then reset and get ready to do it again. Restart, and then run the thing, and then send the script. Okay, and then let's go and find out if there are any more bad characters. This is such an awesome soundtrack. Okay, we need to figure out if the address is the same. So it's FF9EEO. Well, just in case there's something I can't see, I'm going to get rid of all of it. Then I'm going to copy and paste. Okay, this is just a troll now. We've got ads running on Twitch, so we're going to run them on YouTube as well. And let's go ahead and run and give my... Well, actually, it's not time for my favorite... It's not time for my favorite bird video yet. But let's do... Let's do this one. Okay, birds. Here you go. We're going to take about 30 seconds of break. I just need to have a little bit of water. We'll be back in about half a minute. So to anybody who doesn't know, we're doing a we're doing a buffer overflow research session right now. We're trying to figure out what we can include in our shellcode when we try to do our buffer overflow attack to get access to this machine. Aqua, hello Aqua, nice to see you here on YouTube. And let's go ahead and finish our break. We'll put the birds away, and then we'll get back to the hacking. Okay, so we just discovered empty Mount Mao Suri. Let me know how to pronounce your name. MTMA Mount Mao Suri. Welcome to the HackerFrogs. Have a Nyan Cat on me. Banker Doozy, you say that you asking for the Spotify playlist. Very much enjoy this music. So this is the Muramasa the Demon Blade OST. So this is the name of the current song. And if you just look this up on YouTube or on Spotify, well, actually, I don't know if you're going to be able to find it on Spotify, but you'll definitely find it on YouTube. And this is a fun little action hack and slash game. It's got really nice. Well, the gameplay's really good, but the soundtrack is just awesome. Okay, so we're gonna need to add this hex 18 as well. Man, how many of these hexes is it gonna include? Anyways, let's add hex 18 to our bad bytes. Okay, so /x18. Started Volnix after watching your videos. Pretty fun. Preparing for EJPT at the moment. Awesome, awesome. Yeah, Volnix is a great platform. It's a lot nicer to use than VulnHub. VulnHub is the original. But VulnHub is... Man, I can't navigate that site for the life of me. It's really hard to deal with. Okay, let's remove the extra byte. The extra byte is 18. So let's see, over here, we might as well restart this thing now. Okay. VulnHub was the GOAT, but VulnHub is, man, it's showing its age really badly now. And searching for anything in VulnHub, it's not fun. Okay, so let's go over to hex 18. Let's see. Okay. This is much faster. Hex 18, get rid of it. VulnHub isn't great. I was able to get 59 machines out of the 270 or so that they have. All the rest are lost. I think I've downloaded something like a dozen machines from VulnHub. It was really great before platforms like TryHackMe and HackTheBox were well established. So this was like 5 years ago, back in like 2020. Okay, so we replaced our stuff. Let's go ahead and run the script again and see if we can find some more bad characters. Let's see. Try to torrent them all at once just because I know that once they're going to be gone, I'll be sad. Okay, let's take a look. Here? Yeah, here. Okay, let's do the comparison one more time. Now we've got 19 as well. So corruption after 20 bytes. How long is this going to go on? Okay, now we've got to add 20. Am I being trolled right now? Okay, we add 19. And then we're going to restart. Start running the thing again. Let's see. Mount Mao Serai. Mount Mao Serai. This is some low-level stuff. It sure is. It sure is some low-level stuff. So we got to replace 19 now. So hex 19. Come on. This is hex 19. Let's replace it with an FF. And let's run the script again. Okay, so that should have crashed the program again. Yeah, okay. And let's check for bad characters again. So did the ESP change? It did change. So we need to... Let's see. I'm curious, are you just sending it a specific sequence of bytes to try to crash it? So we already figured out how to crash the program. We figured out how to control the EIP. So we've got it controlled with a bunch of 3 characters over here. We're just trying to find bad characters. So characters that we can't use in the shellcode. And we need to do this iteratively, so that... Now... 1A. So at least we skipped some. That's good. So 18, 19... It would have been... Oh no, we didn't skip some. We didn't skip them. Oh man, okay. It's still sequential. Alright, let's add this to the bad characters list. Wait. Man. Okay, so the R desktop just took a crap. We can't click on anything anymore, so I guess we're going to need to reconnect. Another thing we need to do is we need to make sure that the virtual machine isn't going to run out of time. We only have 30 minutes. We need to add an hour. Okay, good thing I looked. Otherwise, if this thing reset on me, I'd be very, very upset. Louis Merez asks, what kind of vulnerability are we looking at? So we're looking at some buffer overflow, stack buffer overflow specifically. And we need to do some fun testing to figure out which bad characters we can include. But this is your this is the glamorous hacking lifestyle right here. We're just doing a bunch of iterative hacking over here. Let's go ahead and make this a little bit bigger. Make it bigger. Oh, what happened here? Did it crash? Okay, let's open up Immunity Debugger again, and let's update the bad characters. So 19. So the next byte after 19 is going to be 1A. So it goes from 9A, B, C, D, E, F. Okay, we got all this stuff in here. Okay, we need to remove the 1A byte as well inside of our script. So the script is here. So we got 1A, we're going to replace this. Okay. Then let's make sure that the server is running. It's not running, so we need to make sure it's running. So we're just going to restart it. And then start the server again. Then we're going to run the script. 3, 2, 1, let's go. Okay, so that should have crashed the thing again. I think, man, we've been doing this cycle so often. But anyways. Let's go ahead and do the comparison. That's why I do it manually. Does doing it manually, like, is that going to help? Is that going to help with the repetitiveness? I don't know if it is. Okay, let's 1B. Is it good? Oh, okay. You can see all the bad bytes at once if it doesn't malform the data after it. Now we got 1B. So we've got... Okay, so 1B. This method feels worse than automation. Well, you know what? This feels really trolly. This feels really trolly. So we got 1B now. I guess we can add this to the bad bytes list. Jeez. You know, at least I've got some good music to help me with the pain. So /x1b. Okay. Do you not maximize the CPU field? I think so. So we would see it in here somewhere, right? But I would need to. Can we show the hex? Can we show the hex view in here? You can follow EBT, EBP, and dump. EBP. Where's that option? ESP, it'll show on the left side. It'll show, let's see, ESP here. Follow and dump, okay. Okay, so we got ASCII over here. We got our hex dump in here as well. Maybe we can take a look at it manually. This is really hard to read. Can we make this, let's see, the appearance, font. It's already in a pretty easy to look at font, but what about font 7? Is that bigger? I mean, it's kind of bigger. It is small. It is small. So where does it terminate? So it terminates over. So we got 14, 15. While AB is that's strange. FF is FF is bad too. Okay, let's replace all the FFs with. Okay, maybe that was the problem all along. We were replacing with FF. Yeah, maybe replacing FF with 01 is what we want to do. Okay, let's go ahead and do that. Good thing we discovered that. Otherwise, we would be here all day. Thanks for pointing that out, or thanks for letting me see that. So I think the reason why. You know, let's go back. Let's go back. So replace all the FFs with 01s. And I think the reason why we were picking up everything else might be because, well, don't do that yet. Okay, well, we'll run it like this. We won't replace 1B yet. It could be that the FFs might have corrupted the next byte afterwards. We might have to start over to 1.5 being the only. It could be. It could be. We could be here for a long time. It's okay. It's okay. This is what we do when we do our low-level hacking stuff. Anyways, let's test this one. That's true. That's true. We can improve our workflow. Hello, Can Do. Thank you. Thank you for coming by, Can Do, on YouTube. Thank you. Let's go ahead and reset this thing. So did we already add 1B? I think we already added 1B here. Let's let's not add 1B. Okay. And then let's reset the server. So restart. Run the thing. Okay. Then let's let's send the evil buffer. So what happened here? So it crashed. Okay. Let's go ahead and do our comparison. And the address is going to be this one. EBP. No. The address is going to be ESP. So this is the ESP. Copy the address. Do the comparison. Okay, so it does say that there's corruption, and it does pick up on the 1B. You know what? We should probably take a look at the bytes ourselves one more time, because it detected 1B again. So what was it? It was EBP, and we're going to follow the thing in the dump. So wait. Why can't I select that again? Oh, no, it's ESP. Follow and dump, okay. Okay, so where was it again? Maximize this. Let's take a look at these bytes. Huh. I wonder why these get corrupted here. These all become AB. Full screen the CPU again, yeah. You know what? I think I'm gonna... So could it be that maybe 14, anything that comes after 14 is gonna get corrupted? Or a hex 1-4. You know what? I'm gonna test something. 1-4 might be the bad byte. So this is what I'm gonna do. In the payload, I'm gonna leave 1-4 here, and then I'm gonna get rid of all these the replacement bytes. So the replacement bytes, they're all gonna go away. I'll keep hex 1B here, and if 1B is still corrupt, I'm gonna remove hex 1-4, and then we'll see what happens. Okay, let's go ahead and do that over here. Okay, so restart, rerun. 1-4 might be the bad byte. We'll find out pretty soon. Okay, so Python send the thing. Okay, and then we will do our comparison. Comparison ESP, let's copy that. It still detects 1B as... Okay, let's do that. Let's do this one more time. So we're going to maximize this. We're going to follow ESPN dump. And everything after byte 14, yeah. Okay, let's go ahead and get rid of byte 14. And then we'll figure out what the heck is going on. Okay, where's byte 14? Here it is. Let's get rid of it. Let's replace it with byte 01. Okay. After that, we're going to reset the thing. You know, this kind of feels good. It feels good to do buffer overflows again. Okay, so it's running. Let's go ahead and send the thing. Control F2 and F9 for restart and run hotkeys and immunity. That's some good advice. Okay, let's go back. So it's crashed. Yeah. Okay, let's do the comparison one more time. Oh, you know what? You know what we forgot to do? We forgot to update the bad characters. Let's update the bad characters. So, byte array bin. No. Okay, so it's going to be X14. I only used B? Well, we've been doing it this way all this time. Wait, let me go back to the TryHackMe page. So mono configuration, fuzzing, crashing, finding bad characters. Compare. Generate a new byte array in Mona specifying these new bad characters along with X00. Update the payload variable. Yeah, I think... Right. Finding a jump point. That's when this comes into play. No worries. No worries. Okay, so let's do the comparison. And with this comparison, we need to get that address. Where's the CPU? Which window? CPU? Where is it? Okay. Let's copy this address. What? What do you mean string out of range? Did I? That's weird. This should be the right address. Hold on. I combined two commands, did I? Mono byte array. Oh no, this is the byte array command. Sorry. We have to do the comparison. So the comparison's over here. Okay. Right. Okay. So it says, now it's detecting 1A. Now it's detecting 1A? Okay, let's take a look at what's going on. So CPU here. Let's follow the ESP. Okay, so what happens after 13? So 13... Man, I have no idea what's going on here. So 13 and then 0, 1 and then... I mean 0, 1... It can't be 0, 1 because 0, 1 works over here. So 1B is actually bad? Okay, let's check the payload and so we replaced 1, 4 with 0, 1. So 1B is bad. 1B is bad? Okay. Let's save this. Let's try this again. So we're going to add 1B to the list. Okay, and then what were those shortcuts? Control F2 and F9. And then... Okay, good. Thank God for keyboard shortcuts. Alright, let's send our bad buffer ahead again. Okay. Alright, and then let's do our test. What is the ESP? Okay, we got ads. Oh man, it feels like the ads are very, very common, but it's just taking a really long time to do this. Okay, we got ads. Let's run an ad and let's put on our my favorite video. My favorite video, the bird bath. Okay, enjoy the bird bath. I'll be back. We'll be back in about 45 seconds. Just have to take a little water break. And have a little stretch if you need it, because this is tiring work. Okay, 1-4. 1-4 was probably okay. 1-4 was probably okay. You know what? We're just gonna take take a little break and watch the birds having their bird bath because man, this is tedious work. You know what's not tedious? Watching birds having a little bath. How about that? Okay, let's put the birds away. Let's get back to the hacking. Okay, so 1-4 is probably okay. Let's just make sure that stuff breaks after where we actually get to, if we actually get to 1A or 1B before we start going on a wild goose chase. Okay, so that we're looking at ESP. I'm gonna follow it in the dump. 1-3. So what did we send after 0-1? So after 0-1 is we removed 1B, and the next thing that we sent after that was 1C. Let's take a closer look. So 1C doesn't appear. What was the last? One A, 1B. It seems to be fixed at 15 through 1C to show AB. Wonder what the write-up says. You know, you can probably look it up. So the machine's called Pila, P-I-L-A. It's from thehackerslabs.com. But let's take a look at this thing in the... So 13 is okay. 14 is probably okay. I'm gonna reinsert 14 just to see what happens. Where are we? Let's reinsert 14. Okay, so the shortcut, what was the shortcut again? It was Control F2, Control F2, and then F9. Okay, let's do it again. Okay, and then get the address for ESP, and then do the comparison. Actually, I think we don't need... I mean, I don't know. I don't really trust the comparison too much right now. But let's do it anyways. Oh, sorry, I did that with the wrong command. We want to do it here. Okay, so it shows 1A and 1B as bad characters. 1A and 1B. So 14, yeah, 14's fine. Actually, no, you know what? Maybe 14... DeepSeek might have some thoughts on that. Some thoughts on which one? 14 might be fine. But I don't know. Hold on. I think 14 might not be... There's a fixed space that gets overwritten or superseded. Okay, let's... Here's the thing. When we take a look at... So, there's 14 here, right? 14's here. 01 is here. So if 14 is actually okay, we should see the 01. But the 01... But the 01 doesn't appear in the dump. So here there's 14. It should be 01 after 14. I think it's actually valid that 14... Anything that comes after 14 is going to be corrupted. Okay. So second line says, I think there's a fixed space there that gets overwritten or superseded, like a limited payload size. Like you need a ROP chain to get to the next spot. That's what I mean. I think it's a fixed buffer size. Like you only have 14 bytes of space. 14 bytes of space. Huh. You know what? Okay. If that's actually the case, we can test this, right? We can test it like this. So we can tell which bytes are fine. And I think everything from 0, 1 to 14 is probably fine. So let's get rid of those. Like send more A's or send C's. Okay. We'll send a bunch of C's. We'll send a bunch of C's. And then we can find out how much, because we can still do this. We can still find the bad bytes even if we have a limited space. So this is kind of painful to do. But let's go ahead and do what? C times, I don't know. We're testing, let's test 20 bytes, right? And we'll figure out how many C's we can actually send. So let's go back. Control F2 and then F9. Okay, let's see how many C's we find in the thing. So what are we looking at? We're looking at ESP follow and dump. So yeah, we are looking at a fixed size. So this looks like how many C's? 1, 2, 3, 4, 5, 6, 7, 8. This is 8, 16, 17, 18, 19, 20. So it looks like 20 bytes. So you need 30 bytes to see it malform after 20. So you need 30 bytes to see it malform after 20. So where could we hide our shellcode? So we control the EBP, right? But how many bytes is there? Because the shellcode is probably going to require, I don't know. It might require quite a few bytes. We should probably, I don't know if any of these bytes are bad bytes then, right? Man, we are sure getting an education today. Okay, so we still need to test for bad bytes. We need to keep sending a plethora of C's. So we're going to try to see if we can get past and actually see our C's in action. Is that what we're trying to do? To see what writes past the 20. Okay. And use ROP chains to move around. Okay. Let's go ahead and go back to the drawing board. Or jumps. Yeah, we're gonna have to figure out how we can jump around. I haven't done this stuff in a while. The buffer overflow stuff that I've been looking at lately has not been very sophisticated. Let's try sending 200. So the problem is if we send, yeah, okay, we'll try 200. We'll see what happens. That's why I was like, yeah, DeepSeek, tell me what I need. Yeah, maybe. Okay, let's reset the dang thing. Control F2 and then F9. But this is fun. Okay, this is very frustrating, but it's also fun. If we can actually get this going, then it'll be fun. Okay, so what happened? So we're still doing the same crash. Sometimes if you send too many characters, you get a different crash, and that would be bad. But let's see what's happening in here. So we never see the C's again. I don't see any more C's. These C's aren't showing up. It's the same number of C's, yeah. Send 1,000 of them. If 200 doesn't work, send 1,000, of course. Okay, let's go ahead and do that. So let's reset. So it's a fixed space limit of 20 bytes to jump. Or 19. Okay. Here. Okay, so it's still the same crash. It's still the same crash. Nothing happens. Nothing happens afterwards. We can send 1,000 bytes. It still doesn't cause anything to show up. So we need to work within. We need to work within these 20 characters if we want to put some shellcode in. 19 rather, because we started at 00 instead of 01. So yeah, we still need to do bad character checking, but the problem is that we can only check a certain number of characters at a time now. Like, yeah, about 20 characters. So that's kind of a pain in the butt. Vrandon Verez. Hello, nice to see you here on YouTube. And you know what? We need to remind ourselves of who we are. Hack the plan, everybody.
Hack the planet! Hack the planet! Shut up again!
Hack smarter, not harder. Oh wow, Hack Smarter's here. Everybody, Hack Smarter is another great InfoSec streamer. Thank you very much. Let's do a shout out to Hack Smarter. Psyched. Oh, hello. Nice to see you here. Nico Zika, thank you very much. And welcome, Raiders. We're just doing some tedious buffer overflow stuff right now. We're trying to figure out how to take advantage of this vulnerable binary over here. We're trying to figure out how much space we have to make our shellcode and what bad characters are in here, and it's been a lot of fun. And by a lot of fun, I mean a lot of pain. Thank you very much for following, Nico Zika, thank you. And you know what? We need to give everybody a special video redeem. How about drink all the booze and hack all the things? Thank you very much for following Not Just Fun, thank you. Thank you very much. And thank you very much for following the Dark Array. Thank you.
This one's dedicated to all the hackers.
This one's dedicated to all the hackers. Cinnamon Toast Rage. Cinnamon Toasted Rage? That's an awesome name. That's an awesome name. Psyched. Thank you very much for the follow. Thank you for the follow, Cinnamon Toasted Rage. Welcome to the HackerFrogs. We're doing hacking. We're doing buffer overflow right now. I'm sorry that I can't make.
This one's dedicated to all the hackers.
And thank you very much for following Ardent Zero. Thank you. Thank you for the follow. Wow. Okay. So yeah, we're just doing this buffer overflow stuff. It's been a long time since I've done buffer overflow stuff on Windows, so I'm just getting myself reacquainted with the interface over here. So let's go ahead and figure out if we can. Good old immunity debugger for overflows. Yeah, this is what I remember. There's probably a better, more modern way to test for overflow stuff, but this is what I know right now. So anyways, let's go ahead and update our... Thank you for Vrandon Verez for subscribing, thank you. Let's go ahead and add another hour to our machine over here. Vrandon Verez says, buffer overflow, what does that entail? What does that entail? So buffer overflow is basically finding a way to take advantage of a binary that in a way that lets you run random commands. So if there is such a thing, if there's a binary buffer overflow vulnerability in a network service, we could potentially get it to run arbitrary commands. But the first thing we need to do is we need to do a lot of research, first of all. And this is what we're trying to do. So we're trying to figure out what bad characters are in the... we just figured out that we don't have a lot of space to work with in this binary here. So after we send our offset and then control the EIP, it looks like we only have about 20 characters to work with to figure out what the bad characters are, and then after that, what shellcode we're gonna send. Because eventually we're gonna use some shellcode to try to get remote access to this machine. The first thing we need to do is, Sick in the Mind says, is it possible that it is the wrong service command that's vulnerable? Wrong service command. If we're if we're actually using the wrong service command, that would be a really bad thing. You know, okay, here's what we could do, right? So it's clearly vulnerable. So I think, I mean, I'm not completely sure that this is the command that we're supposed to overflow. I do know that we've got some space. So after kstat over here, we could start sending our shellcode in this space, right? So this space where all the A's are, we've got about 70. The 19 character limit could be a red herring. Maybe. What I'm saying is that we could put our shellcode in the offset over here, right? We could just, you know, because we've got about, I don't know, we've got a good 60 characters where we could put the shellcode in it over here. And 60 bytes should be enough to write some shellcode, right? So all we need to do now is we need to figure out what the bad characters are. After we figure out the bad characters, we could write some shellcode and then put it in where our offset is right here. So let's go ahead and do that. Okay, so what are we going to do? So we've cleared, let's see, bytes 01 to byte 14. Actually, byte 15, yeah, byte 14. So how many bytes is that? Actually, What was that? What was the script? The script was bad car, right? Python. So these bytes right here. We can cross everything from byte 1 to byte 14 off the list. Let's just save this. To badcars.txt. Oh, huh. Okay, yeah, I shouldn't have done it like that. I shouldn't have done it like that. I shouldn't have done it like that. I should do it like, how do I do it so that it actually saves this stuff instead of interpreting it? Should I do printf? Echo E? Is it echo E? I think there's a typo. Yeah, it could be that there's a typo, sure. Okay. What was it? Okay, let's take a look. Okay, it's still interpreted. Okay, you know what? If I want the literal representations. I don't want all this stuff. Let me ask the AI. Hello, AI. We want to output the literal text in this case, but it gets converted. Help. This is why I use VS Code on Yeah, maybe. Use printf instead. So printf handles hex escapes more reliably than echo e. Run this command. So just do printf. Is that the solution? Well, I mean, we can try. Printf. Nope. Nope. Still doesn't work. I hope you have more suggestions, DeepSeek. Printf, sure. X, verify the output. Nope. Generate with Python. For more control. I don't feel great. Oh, you know what? Let's just create it as a Python file, right? Let's just create it as a Python file. So we're going to, so we can echo all this stuff. That's fine. We're just going to we're going to call this bad cars, bc list.py. Okay, and when we take a look at it, nope, still doesn't work. I'm feeling I'm feeling kind of dumb right now. Oh, you know what? Hold on. We can do it like this. Okay, so this is a Python file. This is a Python, well, okay. Sure. As long as we, is this going to be okay? Is this going to be okay? Shebang, shebang, shebang. Bin env python 3 python. Slyborg, wow, didn't know that you were streaming today. Jeez. Rating with a party of 9. Thank you. Welcome, raiders. We're just trying to figure out some buffer overflow stuff. It's complicated stuff. But okay. At least this stays intact now. Great. How was the stream? How's the stream, Slyborg? And welcome, raiders. Welcome. Okay, let's give everybody from the raid a fun video redeem. How about this one from Jurassic Park? There you go.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Okay, so the bad characters here, we know. Well, actually, these are good characters. We're actually doing a good characters list. Actually, no, we're still doing a bad characters list. So let's get rid of everything until hex 1.4. So that means we can test the next 20 bytes. So the next 20 bytes are Unix system. Unix? It's a Unix system. Unix and Linux are related. Slyborg says, I got through it thanks to chat, but mostly Sumeria. Sumeria, are you here? Let us know. What was your module on? Which module were you doing? Kevin Neem, thank you very much for following. You are now HackerFrog. What are you hacking? What were you hacking? Yeah. I was just repeating the alert thingy. Unix system. No worries. What were you hacking today, Slyborg? Let us know. So these are bad characters. Actually, these are bad characters to check, right? To check. And what we need to do is we need to check the next 20 characters. So what is 20 characters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 14, 15, 16, 17, 18, 19, 20. So we need to check the next 20 characters here. We're just going to copy this. Then we're going to go into our other payload list. I feel dumber for it not smarter. I was doing responder. Oh! Responder. Well, responder's not... Responder, that was... Is that a tier 2 machine on Hack the Box starting point? Or is that still a tier 1? Sick the Mind says, I'm a bad character. Of course. Slyberg, I was talking to you about the difficulty of Hack the Box machines, and how Hack the Box machines that they very quickly become kind of difficult. But yeah, using asking beginners to use responder is kind of a big ask sometimes. Okay, let's nano into overflow. Okay, so the payload is going to be this stuff. We're going to test these characters here with our 20 characters. Let's go ahead and do that. Let's go back and let's reset the box. Ren Perez says, what's the tier hierarchy? So tier 0 is easiest, tier 1 is more difficult, tier 2 is more difficult than that. But tier 0 is easy. Tier 0 is actually easy, because it's all about just interacting with the services in a regular way, in the standard way. But okay, let's send our evil payload now. Overflow. Okay. Responder is fun. Well, you must be a masochist. You'll get used to it. You'll get used to it eventually, is what I'm trying to say. But it's hard. It's hard for beginners. It's not super intuitive. It's fine. Okay, where are we? Okay, let's take a look and see if there are any bad bytes in here. So ESP, follow and dump. I think... What did we end with? So 2.8. I think we ended with 2.8, right? So these are all clear. These are clear. The problem is I'm going to have to do this like 10 more times. I'm going to have to do this 10 more times and keep on clearing these bad characters. Anyways, let's go ahead and do that. So we're going to BC, right? BC list.py. So we cleared everything up until hex 28. Hex 28. So the next set of characters we're going to check are these. 1, 2, 3, 4, 5. We're going to check until... I hate that I have to do this... I hate I have to do this iteratively. Okay, let's check this next set. Okay, and then things come full circle. Alright, everybody, let's go ahead and... So, Slyborg, have you heard of buffer overflow stuff before? Just checking. Because it's kind of... you might have heard of buffer overflow stuff. Maybe you haven't seen it in action before. Let me know. Okay, sending the evil buffer. Let's go ahead and check to see what happened. So the last thing we sent it was 3C. Let me check that. Yeah, so these are all cleared as well. So that means we can get this out of the BC list. It was 3C, right? 3C, okay. Okay, so the next set is going to be this. Okay, and then copy the next payload. Let's get ready to send this thing. You know, the payoff after all of this is done, I hope it's worth it. I really hope it's worth it. Because this has taken a really long time. But that's what hacking is. Okay, so see if sending evil buffer, sure. Let's check. So we need to check if the stuff is in here. So hex 50 was okay. So we're going to assume that, actually, you know what? What's the ASCII range? So the printable ASCII range is, let's see. I think we can eliminate all of these printable ASCII characters. ASCII chart. Because all the printable, well, not all of the printable ASCII characters should be considered okay. So ASCII printable characters, these all came out okay. So I think these are capital letters. I don't know. I think we should keep on going after hex 7A. Because after hex 7A, we've got some special characters over here. So we can get rid of everything until 7A, and I think we'll be okay. So let's go do that. So let's get rid of everything until 7A. Less than 50 bytes. It's about 60 bytes, I think. But the question is, can we make it smaller than that? Okay, so I think here it is, 7A. 7A. We can get rid of 7A as well, we can start at 7B. Okay, so 7B, we're going to check how many more characters we have. Still a lot. There's still a lot of characters to go through. Okay. Sorry. Okay, that's another 20 characters. Scenario 1 are there some task files? What exactly are we doing with this overflow? So, The vulnerable application I got from this. Hold on, let me copy paste some stuff first before I start doing some other copy pasting. Okay, so Sumeria 1, you're asking about where is this from? This is from this challenge over here. So this is, we scanned this Windows box. On the Windows box we found a vulnerable service running on port 9999, and we managed to find the binary file, as well as some other stuff. So the stuff that we're testing right now, we all got from downloading off of this the server over here with the virtual machine. So we're just doing our investigation right now. It's taken a long time, but we're just checking for, here's the thing. It could be that there are 0 bad characters, and then I'd feel really dumb for taking all this time checking. The other thing we could do is we could check for bad characters in our offset, right? So if we take a look at our overflow, we could start checking for bad characters in our offset, because we've got 70 characters to check there. That's going to be a lot faster than checking with the 20 characters we have in our after the return. It's probably the way to do it. That's probably the way we want to do it instead. Because if we crash the program, if we crash the program, we could look in this section for bad characters as well, right? It's probably the better way to do it. Let's. So what would this be? So we're gonna, in this case, we're gonna change our offset to 50, and then we're gonna do prefix plus overflow plus payload plus return, and then get rid of the payload over here. So we just have to remember this, for later. Let me just make sure that this is 20 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 7, 8, 9, 20. Okay, good. I'm downloading the VM, 6.2 gigabytes. Yeah, that looks about right. You need to make sure that the machine really wants to be on a very specific IP range. There's going to be a PDF file that's included with the zip file. Take a look at that, and it'll tell you. Well, I'll tell you right now. No. This is the IP range you want to put it on. You want to put it on 192.168.56 0/24. I hope you heard that. Okay, let's go ahead and send the new thing. Where are we? Okay. Maybe we can start doing this faster, hopefully. What? Bad operand type for unary plus string. Oh, I've got a extra plus. An extra plus in here. Let's see. I heard you figured it out by analysis or just task files. There are no task files in this exercise. I managed to find on the box on the landing page of the web app, there's an endpoint. So the endpoint, when you go to the endpoint that's in the HTTP source, it'll take you to a directory with the two binary files. So 6.2 gigabytes for the Pila box. Let me check. It should be, I mean, I downloaded it a couple of weeks ago. It should be this link right here. I'm not going to download this right now. But let's see how large. Not exactly sure how large it is. Let me check on another screen. Yeah, it's 6.2. Well, I mean, that's what the link says, right? Okay, let's send the evil buffer. So this should be crashed now. Okay, so that's the same crash. We still managed to control the EIP. So if we manage to control the EIP, that means that all the characters are going to be okay, right? ESP, let's follow this. Yeah, so all these characters should be cleared. Okay. So that was everything until I need to check what's in the list. So that was everything until 8E. 8E. So that means we can take the next 70 characters, and this is going to help us out a lot. So cat. So 70 characters. So 8F. I can't do hex math. Hex 0 F plus 70 in decimal. Let's see. Hex calculator. What is 70? 70 in hex. 70 in hex is hex 46. 46. So that's 8F plus 46. Where's my calculator? Hold on, I can probably do this in the calculator app. Okay, so we got hexadecimal, right? Let's see, computer programmer. We're looking at hex. 8F plus 46. Hex D7. Samaria says hex D5. No? Hold on. I mistyped. Okay, if I mistyped, I gotta check it again. So, 8 F plus 46. 8F plus 4 6 D5. Okay, D5. All right, so D5. I guess we need to copy until D5. Where's D5? Here it is. Okay, so you know what? If this works, then we can get this in another two iterations, which would not be too bad. You sunk my battleship. Yup. Hey, Ken BDX, nice to see you here. I was wondering. We had some real big dad jokes appear in the last few streams, and I was wondering when you were going to show up. Okay, let's go ahead and thank you very much for following T1000 Elite. T1000 Elite, great name, great name. Okay, what are we doing? Oh, that's not what I wanted to do. Hold on. I wanted to nano overflow. Okay, so we got our... We're going to set our offset to... We're going to set our offset to 0 right now. Thank you for the great content. Well, thank you. Thank you for watching the content. Okay, so let's... we got our payload right now. We can test 70 of these characters all at once. Let's go ahead and do that. So after we're finished testing the bad characters, then we can start writing our shellcode. Okay, let's see what happened. So that didn't cause a crash. It didn't cause a crash because... No, there was a crash. But... Huh. So something tells me that there are some bad characters in here. Let's go ahead and follow the thing in the dump. So all we need to do is spot what happened. So Samiria1 asks, are you running remote debugger for VM with vulnerable service? So yeah, the remote VM that I'm running is the TryHackMe room over here. So the TryHackMe room is called Buffer Overflow Prep. Buffer Overflow Prep. So this is what I'm using as the debugger. And we still have another hour or so, that's good. But, so what happened here? This should have been 70, or was it 71? How many characters is this? Maybe... Oh, you know what? I think it might be 71 characters. So if this is 71 characters, that means that, yeah. Let me just confirm. I can confirm by doing this. So just remove one of the characters from the payload, and everything should be okay again. Everything should be completely on the EIP. Okay, let's reset this thing. Tiberius made that room. Yeah, Tiberius did make the room. So Tiberius, yeah, was very, very serious about OSCP stuff many years ago. Tiberius is primarily a web app person now, but they used to be very, very serious about OSCP stuff. Okay, so I think we're good. Let's run the evil buffer. That should have crashed the thing. Yeah, okay. For some reason, I miscounted by 1. Web app pays more. Yeah, web app does pay more. There's way less work. There's way less work for network pen testers. There's way less work for network pen testers. Where are we? Okay, so we can get rid of everything until we can get everything rid of everything in the payload. So let's go ahead and go to the payload. So the last byte in the payload is what? I forget. I'll know in just a second. It's D5. So D5 is going to be D6 to D6 plus D6 plus 4-6. D6 plus 4-6. Okay, get the good calculator out again. Actually, it would be D6 plus 4-5. D6 plus 4-5. 1-1B. 1-1B. So this is... it looks like we can just... We can just include all the rest of them. Sykes says D6 to D5, D6 through FF, basically. Okay, so we can get rid of all the rest of them right now. So let's go ahead and do that. Yeah. So let's see. The bad character list was D6, right? D6. Up until FF. Way too lazy for that. Okay. How many, let me count these out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 39, 40, 41, 42. This is 42. Okay. Ken PDX, 42. 42. 42. That's the number. I gotta copy this. I gotta check these bad characters. Okay, so 42 is here, this payload. And we need to... So 42 minus 70. It was 70... 70 minus 42, 68... 28? 28. Offset is 28. Hate to one up on you, but I'm gonna go with 43. You are free to do that. You're free to do that. Okay, let's get this done. Let's get this done. Okay, I just need to make sure that these last set of bad characters are going to be okay, and then we can start crafting our shellcode. Okay, so it looks like everything's fine. Everything should be fine. So there are no bad characters. I spent the last hour and a half. I spent the last 90 minutes figuring out that there are no bad characters for the shellcode. That's a big kick in the pants. That's a big kick in the pants. All right, let's figure out how to do this shellcode. So I forget how to use the forbidden platform, but it's something like something. I'm sure it'll teach me in the room over here. Let's go ahead and do that. Samaria1 says, enlighten me, you put the binary inside the THM box, and how are the PILA and THM boxes connected? The THM boxes are not connected. The THM boxes are not connected, but I needed a Windows box to do my testing on, so I decided to use this this THM box. So this is basically a debug lab, yeah. So that's why I'm using this box. Okay, let's switch up the music. Let's play some. Oh, let's play some Valhalla. Okay, so let's see. So we've skipped this step, crash replication, and controlling the EIP. So let's see, finding bad characters, we finished this. Sick the Mind says, I gotta set up a couple of Windows VMs for a debug lab. So I don't have the VMs, so that's why I'm using this the TryHackMe machine over here. So let's see. So we found all the bad characters. The next part here is finding a jump point. So let's see. Run the following Mona command option with all the bad characters you identified, including X00. This command finds all the jump ESP or equivalent instructions with addresses that don't contain any bad characters specified. The results should display in the log data window. Choose an address and update your script, setting the return variable to this address. So Sumeria 1 says, so THM is practice, and you will blindly send payloads to Pila. Well, I'm hoping that the environments are similar enough that it's going to work. If it doesn't work, then it could be that all my work is for nothing. But you know what? It's a good experience trying to get this working in the first place. For some reason, I get the feeling that the people who designed the Pila box are probably looking at exercises like this as an inspiration. Yeah, no, I copied the vulnerable Pila app over to the THM box. That's what I was talking about, the copied binary. Yeah. We did copy the binary over to the THM box. Okay, so well, I mean, maybe we can skip the finding the jump point, because we can probably put our shellcode inside of if we can put our shellcode inside of the first 70 characters, then we should be okay. Okay, we got ads running right now. Let's go ahead and run them on YouTube, and then let's watch some birds. How about these birds? There you go, buddy. We'll be back in about 30 seconds. Thank you very much for following Sumeria1. And I appreciate all the insight you've got, because you probably have more experience than I do. Well, the way I'm guessing that you have more experience than I do when it comes to buffer overflow stuff. But yeah, welcome to the team. Welcome to the HackerFrogs. Okay, let's put the birds away, and then hopefully we can write some shellcode. Okay, so it looks like we're using this command right here. We need to adjust it, of course. Okay, so we need our IP and our listening port. What's my IP address? Let's see. Sick the Mind says it'll be fun to find shellcode that'll fit inside the byte constraints. Yeah, we're looking at ton 0 in this case. So ton 0 is going to be, let's update this. So ton 0 is going to be this one. Where was it? Here, right? I can just use ton 0. Can I? I've never done that before. But let's see. I don't think I need to adjust anything else here. My IP is ton 0, you can just use ton 0. Oh, really? Okay. I'm probably want to use a staged payload. Staged payload. What's the option for stage? Well, let's see how many bytes this takes. Oh, this is probably larger than 70. Payload size, that's too big. Maybe I do need to find a jump point. Okay, let's see if we can find the stage payload. Okay, how many is this? This is even bigger. That's This was only 351, but the staged one was 402. That's weird. Yeah, why is that a thing? That's Okay, maybe we need to find our jump point then, because I can't work with this small of a space, right? Encoding with... Oh, the encoding. The encoding, yeah. Oh, what are we looking at? Well, I mean... Yeah, okay. Let's go ahead and find our jump point. Okay, so jump point, find the jump point. So whether when it's running or in the crash state, run the following Mona command. Update the CBP option with all the bad characters you identified. So let's go ahead and do that. With the K, I forgot what ITW is. ITW. It was. I forgot what it was. Do we know 100% is that the command with the K? With the K? Are you talking about kstat? I mean, we've been using the K. We've been using the same prefix this entire time. Yeah, no, we've been using the same prefix the entire time to crash the program, so it should be well. It should be okay. There was a dozen. There were a lot of them. Yeah, you sure that was the one? I mean, I did testing with a bunch of the other. With a bunch of the other commands, and we didn't seem to crash when we were using the other commands. I didn't go through systematically. But let's try to discover a jump point, because we can't work with 70 bytes, because any shellcode is going to be way bigger than 70 bytes. Okay, so where are we supposed to be looking here? So this command finds all of the jump ESP or equivalent instructions with addresses that don't contain any of the bad characters. The result should display in the log data window. So let's go ahead and switch over to the log data window. So we got 9 pointers. Using that command, that's the limitation. Maybe. So what are we looking for? We're looking for... So something in the essential function DLL. And I'm sorry that if you can't read this, let me see if I can make this a little bigger. Oh, I can make it a little bigger. Okay, sure, sure. This is better. Okay, so we got 9 pointers with jump ESP. I just need to figure out which one of these is going to be appropriate. What does it say here? So choose an address and update your script, setting the RTN variable to this address written backwards, since this system is little endian. I'm pretty sure we're dealing with the little endian binary in this case as well. So generate the payload, okay. Copy C-coded strings, integrate them into the file, into the script. Prepend nops. Oh man, we're getting so close. So I guess they're looking for some no operation stuff. They in the example here they're using 16 bytes. I guess we could, I don't know. Okay, let's find one of these addresses as our jump point. Oh no. Need to go back. Oh geez. It looks like our connection froze up again. Okay, we're gonna need to redo our connection. Our desktop sure is fun. And by fun I mean not fun. Okay, let's make this a little bigger. Okay, we need to look at the log window, log data. And this is the, let's try this address. Let me just type it out in chat so I can keep track of it. So this is what, 62501203. And what is that written out backwards? When we read it out backwards, it looks like it looks like 03125062. And we need to put some of these. Okay, so this is going to be the return address in our script. So the return is going to be this. And our payload, oh, we need to change the sequence of the payload. So it's prefix overflow payload return payload plus padding plus postfix. Digital Warhead, hey, haven't seen you in a while. Nice to see you here. Welcome to the stream. We're just doing some buffer overflow stuff. Plenty of fun. Let's get rid of this. Okay, we need to get our new payload. So the payload is... Let's save this. Actually, wait. Yeah, let's save this out for right now. Let's get the payload. So the payload we're creating with the Forbidden Platform, and it's all this stuff. So let's go ahead and copy this, I think I need to copy... When I copy this, do I need to copy it with the semicolon or not? Okay, so we've got payload pasted in. I hope this goes through okay. It should go through okay. Everybody's been using this thing. So, I don't know. I think we're supposed to put in some padding as well. I think they used... what, 16 no operations? A times offset. We need to make sure that the offset is correct. It's 70. Okay. So if it actually works, then we need to set up a reverse shell listener. And I guess I'll set up the reverse shell listener in another tab. We'll call this shell access. Let's make this purple, because purple's nice. Our RL wrap, and then we'll use a netcat listener on 443. Where are you jumping to? So we're jumping to this address that we found where we've got a jump ESP instruction. So this address right here. So wait, let me review this. We find the jump point, okay? So choose an address and update your script. Okay, setting a return variable to that address written backwards. Okay. Generate the payload. We generated the payload. Copy the generated C code strings and integrate them into your script using the variable with the following notation. Oh, wait. The notation has to be... Oh, we got to put it as an array. Okay, never mind. I need to change up my my script. If you grabbed jump ESP, it's going where the C's are. Where the C's are. Hold on. Okay, we need to make the payload an array. So the buffer is going to be prefix overflow return payload padding postfix. Oh, it's going where the C's are. Okay, so what do we do if the payload is... Oh, dang. What can we do about this? I don't know if there's any other place we can control that's going to fit this payload. Well, if anybody has any suggestions, please let us know in the chat. People who are more experienced with buffer overflows than I am. So we're going to have to fit our... That's why I was suggesting the kstat as the red herring a bit ago. Okay, let's... If kstat is a red herring when it only had 19 bytes. All right. Let's suppose it is a red herring. If that's the case, we need to find our crash again. So let's try that. So we've reset everything. Let's go ahead and well, we'll save this for now just in case. Should be easy. You've got the proof of concept for it. Okay. What were the other commands? So we can actually go into the box here. We'll connect to netcat. What was the address? Break out netcat again. Of course. Netcat is our friend. Okay, so what are the commands? We've got all these commands. There's like 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 different commands to work with. So, for example, if we do like kstan and then some value, let's make it a bunch. Send 10k to each of them. Let's see, is there no automated tools to kind of brute force which passwords are crashing the service, or did you make my payload by hand? So basically, I kind of winged it. I would just send like I would just create like a bunch of these. Actually, I should be using like an automated method, right? The automated method is probably the better way to go. So send 10k to each of them. You are more pay. Wow. I don't know. So let's go ahead and test kstan with a bunch more. So kstan bum, and it's still okay. So kstan much more. Unknown command. Did it crash? So it hasn't crashed yet. I would have looped with all these commands with another loop that hits each one with 1,000 bytes at a time until crash. Maybe that's the better way. That's probably the better way to do it. You know what? Maybe I'll use the fuzzer script. So they suggest a fuzzer script in this room. So basically, you can set whatever you want and then send as many. You can set as many whatevers you want. Yeah, that's the one. That's the one. Okay, let's get out of here. We'll just call it fuzz.py. Okay, and yeah, this is the right one. Let's try. So we'll try kstan, right? We got kstan. We got the prefix times 100. So fuzzing with 100 bytes, 200 bytes, etc., etc. Okay. Oh, wait. We have to change the port because the port's different. Okay. And where's the ceiling? There's no... I don't think there's a ceiling. I don't think there's a ceiling defined in the script. Or does it keep on going until it dies? Well, I mean, if we see some absurd numbers... When we see some absurd numbers, I'm guessing... Well, I mean, I don't know. When we get to 2,000 bytes, we can consider... When we get to 3,000 bytes, maybe we can consider, like, you know, stopping the thing. You wouldn't stop at 3K. How many would you stop at? Do we stop at 5K? It could be upwards of 10K. I think they wouldn't be that... I don't know. I wouldn't say that they would... I would say they wouldn't be that cruel, but maybe we should... Maybe we shouldn't underestimate. You never know when it's a CTF. It's over 9... Let's stop at over 9,000. How about we follow Cypher Enigma's good advice? We'll start at over 9,000, and we'll send 1,000 bytes the next time. Change it to 100 per request. I think we should change it to 1,000 per request. Okay, so what were the other... Let me get the other commands first. So let's... Oh, okay. Shouldn't have done that. Shouldn't have done that. But you know what? Let me grab the IP address while I'm here. I just want to get the list of commands. So these are the commands. Okay, we're gonna hit 9,000 pretty soon. Implement binary search of crash window. Samaria asks, what dictated expected buffer size, by the way? Expected buffer size. So I just started, winging it. And let me create a file called, what is it, commands.txt. Just so I can get a list of these commands. Okay, so we're going to switch out the command. And we just tested the kstan command. Let's try the lter command. So not kstat. It's not kstat. We know that kstat, we got our initial... Well, we've been doing all of our testing assuming that kstat was the one that we were looking for. Let's edit fuzz.py. Kstat speaks lies. Maybe. So LTER is the next one we're going to test. And let's send 1,000 bytes per request. $1,000. Oh, huh. It only increments by 100. Hold on, let me... Where's that loop? So 1,000... Oh, string plus... Okay, let's send 1,000 each time. Okay, 2,000, 3,000, 4... What's the next one? So the next command is kstan lter chter. Yeah, that's probably not it. So the next command is chter. Samaria1 says, having binary isn't easier to find out the buffer size by reversing, or is it cheating, or is it not that simple? Put all those commands into your script as a comment block. You know, that's probably the right way to... Ooh, we crashed. We crashed at 3,000 bytes. Okay, okay. Hoi Minoy says, can you explain what you're doing? I'm fuzzing commands for buffer overflow. So basically, some programs, if you feed it enough information, it'll crash the program. And if that kind of vulnerability is present, then it could potentially be attacked to get arbitrary command injection. Okay, okay. So what is the command we're using right there, right? That was the chter command. So maybe that was a rabbit hole that we're going down. So, okay. chter, we need to figure out what the neighborhood of the offset is going to be. I think we should inspect all of them. Save htr3k. So it's going to be between 2,000 and 3,000 bytes. So let's see, echo htr 3,000. So yeah, it's basically yelling at a program until it crashes. All of the A's, and then, you know, and then it dies. I would honestly use notes in my fuzzer script. I probably should. That makes a lot of sense. So we need to figure out what the offset is. So let's start at 2000 and then increase by 100 each. So we'll start at 2000 and then we'll fuzz by 100. RCE, potentially. Fuzzing crashed at 2000 bytes. Wait, is it actually under 2000 bytes? Hold on. Let's start at 1000, and then we'll increment by 200. No. The reason why it didn't work is because the program is crashed right now. I forgot to reset this. Silly me. What restores the service after a crash? I restore the service after a crash. I restore it. I was just being silly. Okay, let's go back in. So we're gonna check for 2000. And we're going to increment by 100 to figure out what the exact offset is. Okay, 2100. So, okay, it's between 2000 and 2100. Okay, we got an ad running on Twitch right now. So, ad on YouTube. And I don't know, how about the Greedy Sparrow? Here you go. Enjoy. This is the greediest sparrow that won't let anybody else near the food bowl. Okay, I'm going to take a little water break. I'll be back in a sec. Psych says, ad is done for me. Okay. Let's go ahead and put the birds away. Thank you very much for following. 44 rune, or I'm not sure what else to interpret that as. Okay, so it's between 2000 and 2100 bytes. We can narrow that down even more. We can just send 20 bytes. Air rune? Let us know. You're now HackerFrog. And let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up again!
Okay, let's reset the server again. I think I must have reset this server at least 50 times by now. Aaron. Oh, okay. That's great. Let's figure out. So this is going to be between 2000 and 2100. So let's send 20 bytes at a time to figure out where the crash happens. Aaron, if you know, you know. Well, so the crash happens between 2020 and 2040 bytes. We can probably, if we narrow this down even more, we can probably figure it out. So let's send 4 bytes at a time. Actually, we're going to start at 220, right? Oh, no. Start at 220. And we need to reset the server again. $228, $224, $228, $232, $236. Okay, so it's probably 236 bytes. It's probably 236 bytes. We could probably find out for sure by doing a pattern. Let's do the pattern 2036. Okay, so this is the pattern we're going to send. And we're switching over to the other script now. AA Rune has cheered 500 bits. Thank you very much for the bits, AA Rune. Much appreciated. Thank you. And you know what? Let's give you a special video redeem. What haven't we done in a while? This is really good. It's from the Batman movie.
What are you?
I'm System Root.
This is where you want to avoid red herrings. See what your bytes after the break are to see what kind of space you're working with. Yeah, okay. Alright, so the other script we're looking at... Hold on. We gotta copy all this. The other script is called Overflow. Okay, so... What was the offset? Well, actually, we don't know what the offset is yet. Let's comment out the payload here. What was it? Triple? It was triple quote, right? And triple quote over here. I don't know. Is this stuff actually going to get quoted out? I think it needs to be on a new line. Okay. Okay, so the padding, well, I mean, we don't really need to, I mean, we don't really need to send the padding right now. That's fine. Should be good. Okay, keep on going. So the return, well, I guess we don't need the return right now. So we're going to send the overflow. So the overflow, the offset. We're going to set the offset as 0. And we're not even going to send the offset. We're just going to set the overflow as this thing. Let's see. AA Rune says, I have to confess that to keep me awake while programming, I've been using Hacker's 1995 movie as background for more than 10 times now. So 2036? I think... Well, we'll see. Well, I mean, the pattern is... really big. It's 2036. Right. So we need to figure out... I ain't never seen a virus sing to me. Okay, let's go ahead and send the... Okay, first of all, we need to reset the server. Because it's crashed. And then we need to run the thing. Then we need to send the thing. Whoops. How much time do I have left? I only have 30 minutes. Yeah, okay, we need to add another hour on here. I've been working on this for like over 3 hours now, I think. Or at least it feels like it. Okay, so let's go ahead and send our That's what the challenges are for. Yeah. Usually I'm not killing myself this hard to get this done. So the EIP is this. So let me copy the EIP and let's find out what the offset is. Okay, so it's rag 2q this. What do you mean 70 and 71? That doesn't make any freaking sense. No. What's actually going on here? Reverse? Do I need to do this in reverse order? So it would be 4141 4141 I mean, we would just switch this. Hold on. Yeah. Something tells me that I'm doing this wrong. Because this should not be the case. I didn't change the command. Which command? You're still using case. Oh, I'm still using kstat. Wow, you're right. Sick in the mind. You are very sharp. You're very sharp. I'm very dumb. It's htat? Was it htat? I need to check. Htur. Htur. And whatever result we get from this, we need to subtract 1, 2, 3, 4, 5. We need to subtract 5 from whatever we get. Okay, let's do it again. Okay, looks like it's working. VS Code on Kali will save my life. Probably. I need to get with the times. Huh. Did this crash? It doesn't look like it crashed. It does not look like it crashed. Let me reset the program. So that should have been how many characters? There should be 2036 characters. Do I need to add some more? That doesn't seem... Try sending 2040. So let's... Yeah, that might be... Okay. Let's try replacing the thing. Okay, let's set up the server again. I think it's already set up. Great. All right, let's send the thing. Hopefully it crashes. No, it didn't crash. Is it not Is it not crashing? What the heck? Terminate code 0. Just joined listening. I have no clue what you're doing, but looks interesting. I'm just starting to learn code myself. Rusty Guitar, hello. Nice to see you here on YouTube. We're just doing some buffer overflow attacks. So buffer overflow attacks are when there's a vulnerable program that that crashes when you send enough information at it. And after you send the information that crashes it, you can try to find a way to have the program run arbitrary code, which would be a really bad thing. So I think, okay, this is what I'm going to do. I think the payload, this code might not be getting quoted out correctly, so I'm just going to get rid of it for right now, because I'm kind of paranoid. So prefix plus overflow plus return plus payload plus padding plus postfixed. So overflow is this. I'm going to try resetting the thing. Actually, we don't need to reset the thing, because it's still running. Terminated exit 0. Okay, it didn't crash. Okay, so this is when Sumeria 1 says, what does steganography have to do with buffer overflow? You need to find some stego data after getting shell. So steganography was like 4 hours ago. We started the stream with steganography, and I just haven't updated the stream since. I haven't updated the stream's title since. But yeah. Steganography was it feels like ancient history at this point. Okay, let's do this. So the overflow, I'm just going to make sure that this is working and that I can use the script to overflow. So that's 2040. Let's just send 2040. So it's going to be, overflow is going to be A times offset. And I think I might be able, I might have to call it pretty soon, but I want to figure out if we can, I'm going to figure out if we can actually make some progress on this box. Because it would be awful nice if we could start making some progress from stream to stream. Okay, so let's run the thing. Whoops, here. Okay, so that worked. I don't understand why. What happened here? So the EIP has a bunch of stuff in here. Digital Warhead says, if you use steganography to write a photo of a stegosaurus, the dinosaur is so big that it causes a buffer overflow. True. Too true. Let's, you know what? We're pretty close. We're pretty close with 2040. We just need to figure out some very fine modifications. Whoops. So this is what we're going to do. We're going to do 2036 here. Actually, let's do 2032. And then for the return, we're going to do a bunch of 3s. How about, we'll do 4 3s. And then we'll see if any of these end up in the EIP. The thing I'd be doing first is just doing simple A and B payloads, narrowing down that offset. Yeah, I think we're pretty close. We're pretty close. Okay, so none of the threes made it into... None of the threes made it into the EIP. So that tells me that we're sending too much. Let's reduce the number of the offset by 32. Let's do 28. Okay. Let's reset the thing one more time. Second the Mind says, the thing I'd be doing, just follow the ESP in dump. Just follow the ESP in dump. It's probably the better way to do it. Let's do the thing one more time. Okay, the A's... Something weird happens here. What is in the EIP? The EIP is 75BA? 75BA? Where is it? You don't want to end up with another red herring, which is why I was suggesting just note down where your estimate buffer overflows were for the commands, and then determine which one seems most feasible to potentially allow you to write remote code that's usable. Yeah. I wonder, access violation writing to AAAA. So the EIP, so we don't see any of the characters in here. I mean, I wonder what's going on with this, with our payload. It doesn't seem to be landing. Okay, let's reset the server. Go again. Okay, so how many bytes are we sending right now? So this is 2032. 2032. Let's send 4 less and see if it actually causes a crash. So this doesn't cause a crash. This is not enough bytes to cause a crash. So right now we're sending 2028, and that's not enough to cause a crash. If we add 4 more, this is where we were at the beginning. Oh, you know what? We're sending. No. It's This is. I don't know. Anyways, let's try again. So we'll send 2030 this time. You could have easily fuzzed it again with 2 at a time until crash. Could have. Could have. That would be too easy. Why would we make things easier on ourselves? Anyways, let's go ahead and run the thing. Did it crash? It didn't crash. Okay, it didn't crash. Let's send another 2. It did crash. So it did... Okay. It did crash, but there's none of our data in the EIP. Okay. This is what we're gonna do. We're just gonna do. Let's reset. Inspect the ESP. I already reset it. We'll do it next time. Okay, we're just gonna use a bunch of 3s, right? Okay, so return is gonna be 3 times. I don't know. Let's just say 200. 200 3s after 2028 A's, and we'll see what happens. Use 1, 2, 3, 4, 5, 6, 7, 8, 9. I just want to see where these 3s end up, if they end up in the buffer at all. So let's. Okay. Okay, now we are putting these 3s in the EIP. Yeah, something weird happens. Let's take a look at the BP and the ESP and follow and dump. So, yeah. A's over here, and then 3's over here. That's not a lot of bytes. That is not a lot of bytes. Well, how many is this? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 3? I need 12 times 3. No. This is... Yeah, 12 times... No, 12 times 8. 12 times 8. What's 12 times 8? My math is bad. It's actually not... It's not too bad. 12 times 8. It's 96. I need 300 plus. I need 300 plus. Okay, you know what? Here's the thing. We can hide the shellcode inside of our offset, right? Samaria says, a little off topic, conceptually you want to still kill the service. Last action from it would be opening a remote shell to you. Yeah, that's the goal. The goal, I think we're okay. So, sick in the mind, we have so much room to work with because our offset is like 2,000 something bytes. So we could potentially put our shellcode in the offset. And that would work, right? Thank you very much for following Raku Rai. Thank you very much. You're now HackerFrog. Let's give you Nyancat. Okay, we made a lot of progress today. I think we've got a place where we can insert our shellcode, all that good stuff. But I need to end the stream pretty soon, because I'm getting tired and hungry, and I'm not myself when I'm hungry. Anyways, let's see if there's any great InfoSec streamers on right now. HackerWitch is on. Let's check out what HackerWitch is doing. You should check for... I don't think we need to check for bad characters again. So Sumeria, we're already confirmed that there are no bad characters. Why are we looking at that? What are you doing, Hacker Witch? Okay, let's see. Day 3 of befriending something something. Okay, we're not doing infosec here. Let me take a look at my Twitch list. If anybody has any suggestions for who to raid, I'm very happy to take those suggestions. Sly was also thinking about her. Okay. Let's do Quantum Apprentice. Or actually, we can do science streams. Actually, maybe, yeah, let's do Quantum Apprentice. So Quantum Apprentice is, let's check out what they're doing first. They're doing software, they're doing C and C++ stuff. Let's check them out. Hold on. Quantum Apprentice. Here we go. Okay, so Quantum Apprentice is doing some game development. Okay, it's between Quantum Apprentice and science streams. Let us know in the chat who you want to raid. If it's science streams, type ants. If it's Quantum Apprentice, type app. Sprites on sprites. Yeah, looks like it. Looks like we're doing some game development over here. But the science streams, they're doing science news. They're talking about all sorts of stuff. Hopefully we don't get more ads before we get to see what they're doing. So they're doing, what is this? They're talking about CRISPR tech, new species development, anti-venins. Don't know about this, but they're doing science stuff. So it's choice between small streamer and slightly larger streamer. Okay, let's small, of course. Yeah, let's do science streams. We haven't rated them in a while. So science streams. Okay, so everybody, thank you very much for coming by. And is there any conspiracy theory science streams? Just Alex. I don't think so. I don't know. But before we go out, let's do one last Hack the Planet. Thank you very much for everybody for all of your great insight today.
Hack the planet! Hack the planet!
We'll be back on Monday, and we're going to be doing more digital forensics and more Linux hacking and all sorts of fun stuff. Hope to see you then, and we'll see you next time. 3, 2, 1, HackerFrogs out.